Hey everyone, welcome to this tutorial, where we're going to start with a brand new Android project and see it all the way through to publishing on Google Play. My name is Rahul and I'm a software engineer and YouTuber who loves teaching. I think the best way to learn something is to build things, and so we're going to build a memory game app to learn Android development with Kotlin. As you go through this, if you have any questions or feedback, I'd love to connect with you. I'm at rpande1234 on YouTube and Twitter. The memory game is the perfect way to cover a lot of core Android concepts. We'll talk about dynamic layouts, multiple screens, image loading, and persistence with Firebase. Along the way, I'll share some practical tips and tricks about app development and my checklist that I always go through before publishing any app onto Google Play. I'm going to assume you have some programming experience, and if you have a basic familiarity with Android, that's an added bonus. We're going to be using a programming language called Kotlin, which is now the recommended way to develop Android apps. You're welcome to follow along if you're new to Kotlin, or even if you're new to programming, but I'd recommend that you go through a quick Kotlin intro first. Once you're done building the app, share it on social media with the hashtag MyMemory. And don't forget to tag me so I can check it out as well. Let me do a quick demo of the memory app that we're going to build. This game is really popular. I played it a lot growing up, and I'm sure it's familiar for many of you. The objective is to try and find pairs with matching images. So here I have two cards which don't match. When I flip over a third card, then the other two will flip back down. And the reason this is called memory is because once you've identified where an image is, you have to use your memory or concentration to find out where have you previously seen that card. So here, I know the matching flower image is over there, and now I can continue until I have found all of the pairs. Once I've found all the pairs in the game, then the confetti falls and I have that message, and we can also see information about the game at the bottom of the screen. In the menu, I can tap this button to restart the game, and that shows me new random images. And I can also choose a different size memory board. So right now we're showing an 8-card game, which is 4 pairs, and I can make it a little bit harder by choosing the hard version, which is 24 cards. And so now you can see how we are dynamically changing the size of each memory card in order to fill up the phone width and height. One other thing we can do is download a custom game. So this is a really cool part of the game, which is that anyone in the world can create their own memory game with photos from their phone, and we can actually play that. So for example, I created a custom memory game called Bitmoji. So Bitmoji is my Bitmoji character, my cartoon, doing different activities. And so now, if you flip over a card, you can see these are images from my phone that I uploaded into a custom memory game. And we can play the game like normal, where we're trying to match up images. And finally, of course, you can also create your own custom memory game. So I'm going to choose to create an easy game, which means I have to upload 4 images. This will now launch the existing gallery app on your phone, and I can select photos from my phone. So I have these very adorable photos of corgis. I want to give this game name the name of corgi and tap save. And what this is doing is it's persisting these images to Firebase. And once that's done, now we can actually play our custom game. So you can see the images of the corgis that we have here. And the cool thing is now I can share this game name, corgi, with anyone in the world, and they can play the same game. So there's a lot of really cool concepts that we're going to cover in the process of building this, and I'm really excited to get started with you. I'm going to make it really easy for you to follow along with me, which means I'm going to keep copy-paste to a minimum, and the only tools that you really need are Android Studio and a working emulator or a phone, an Android phone. I'll also leave a link in the description to the GitHub repository, which contains all the code, so you can feel free to reference that as well. Here's a picture cloud representation of the main concepts we'll be covering. So first off, we're going to become very familiar with Android Studio. We're also going to be talking about vector icons. So Android Studio will help us to create a bunch of these vector images that will be used as the default memory game images. We'll also talk about views and measuring out how much space to allocate with the content, the padding, and the margin which lives outside the view. All that content will live largely inside of a RecyclerView, which is how we're displaying the grid of memory cards. So RecyclerView is a very core component in Android, and we'll talk about the different parts that make up a RecyclerView. We're also going to be dealing with 2 Firebase services. The first is cloud storage, which is what we'll be storing our images. Second is Cloud Firestore, which will be the database associating our game name to a list of image URLs. And then finally, we're going to spend a bit of time talking about how do we create a release app that we can then publish onto Google Play, and also talk about how to optimize your Google Play store listing. I'll leave a link to the published app in the Google Play Store in the description so you can download it and get a better feel for what exactly we're going to build. All right, I hope you're excited to get to work. In the next segment, we are going to construct the layout for the main screen or main UI for our application. Just one more thing, I wanted to say a big thank you to freeCodeCamp for building out an amazing platform to reach so many students. Subscribe to their channel and check out my channel if you want more content like this. We're going to get started by creating a brand new Android Studio project, and then the goal for this segment is to set up the scaffolding for the main layout or main UI for our memory game. Here's what the final user interface for our app will look like. At the top, we have an action bar, which comes in by default in every Android app, and it describes how the user can navigate through your app. The bulk of the screen will be taken up by something called a RecyclerView, and that's how we're going to power this grid of memory cards that make up our memory game. At the bottom, we have two labels or two text views that describe the current state of the game. And so at the end of this part, here's what our UI will look like. At the top, we have the default action bar. At the bottom, we have a horizontal linear layout with two text views with dummy data, and the rest of the screen will be filled up with an empty recycler view. Okay, let's open up Android Studio, and you can see here that I'm running version 4.1. Any recent version of Android Studio should do. So I'm going to tap the option for creating a new project. And let's go ahead and pick the empty activity template, tap on next. And we're going to call this project My Memory because it's a customizable memory game. The package name has to be a unique identifier for your app, and it will dictate the directory structure for your project. Typically, I'll take my domain name, arcadeplanet.com, or my email address and flip it backward. Pick a location for where you want to save it. We're going to pick the language of Kotlin, which is the more modern and recommended way of building Android apps going forward. The minimum SDK, I'm going to pick API level 21, which is Android 5.0, otherwise known as Lollipop. And you can see here, Android Studio is telling us that if we pick API 21, that means our app will run on 94% of devices. So that means around 6% of Android devices are running a version of Android which is more than 5 years old, and they won't be able to download our app. But there's a lot of pain associated with actually backporting your app and making sure it runs on all these super old Android OS. So I would recommend that you stick with API 21. Let's tap on Finish. And then Android Studio, initially when it creates your project, it will actually try building it based on the scaffolding that you picked. So we have empty activity, which means that we just have a kind of a blank activity here, which will say hello world. And the very first thing I like to do whenever I create a brand new project is simply to run it. And running it will give me the confidence that I haven't screwed anything up in the setup. I have Android Studio set up properly. I have an emulator set up properly, and I'm actually able to compile and run my app. I have a bunch of emulators already set up here. If you don't have any emulators, click on AVD Manager, it's Android Virtual Device Manager, and that will guide you through the process of creating a new emulator that you can install the app on. I'm going to go with this Pixel 2 API 29 emulator. And without making any code changes, I'm simply going to hit this green triangle in order to run the app and boot up the emulator in the process. Okay, awesome. So you can see down here at the bottom how it says the operation succeeded. And just like we want, we're able to see this default empty application, which says hello world. So let me quickly talk through what we get in the starter project here. So there are really two files that you should be concerned about. One is the mainActivity.Kotlin file. The .kt means it's a Kotlin file. In the world of Android, you can think of an activity like one screen in your application. So this file, mainActivity.Kotlin, will be where we write the core logic for the memory game. It'll be the brain of our app. And the critical line here is set content view r.layout.ActivityMain. So what this is referring to is that there is a resource file called ActivityMain. So R stands for resource, and r.layout means look inside of the layout directory of the resources and look for a file called ActivityMain. So we can actually try doing that. So my preference is to select the Android view of our project. The initial perspective, which is simply called project, represents the actual file hierarchy of the project on disk, but it's a little harder to navigate. And the Android view is how I conceptually think about my project. So instead of the Android view, in the app directory, there's a folder here called res, which is short for resources. So like we talked about, there's a layout directory inside of res. Let's check that. And there's one file here called activity main.xml. And that's what is creating the link between the main activity and the underlying UI or layout. So I can go to the definition of activity main by hitting Control B or Command B. And that will jump to this other file, activity main. In Android, we define layouts using XML, a markup language which allows us to define the views on the screen, their position, and how they're structured with one another. So you can have views inside of another view. And you can see here how it's really simple right now. All it is a constraint layout as the root element, and inside there's a text view which just says hello world. And that is how we are seeing the hello world text when we ran our application. Now we can start making changes. And I want to be really precise about what we're going to do in this segment, which is I just want to add a bottom component which will describe info about the current game being played. In particular, there'll be two text views, one for the number of moves on the left and one on the right side showing how many pairs have been matched. So that means we're going to have to be modifying the activity main.xml. And you'll notice here that there are three different perspectives of this XML file. So we have the code, which is basically the underlying XML representation, split, which is both, and then design, which is just looking at the preview rendered in Android Studio itself. So to give ourselves a bit more space, I'm going to double tap on activity main, and that basically minimized this project tool window. And the first thing I want to do is just get rid of the default hello world. And we are now going to drag out a linear layout, which is horizontal orientation, because these are going to be right and left. The two text views at the bottom are going to be horizontally aligned. And we are going to set the layout width to be match constraint, which means that we're going to have the width be dictated by the constraints. That means now we should add some constraints. So from the left end of the screen, I want it to be 0 dp, which means I want it to be flush with the left end, and same thing on the right. And essentially what that did is it's making the width of this linear layout the whole screen width. We also want to constrain the bottom of this linear layout to the bottom of the screen. So add 0 down here as well. I also want to change the height of this to be wrap content, which basically means I want the linear layout to only have as much height as whatever is inside of it. Inside the linear layout, we are going to contain two elements, and these are going to be card views. And the card views are actually what will contain the text views. So card views are a really nice Android component which show some elevation. So it's a material design recommended UI. So that's what we'll use to create some separation between the text views. And we'll actually also use it for each memory card. So I have a card view here. I'm going to change the corner radius to be 8 dp here. And then inside of the card view, I want to drag out a text view. So a couple changes I want to make here. First off, I want to make the width and height to be match parent. So this text view takes up the whole width and height of the parent, which is the card view. I want to make the text appearance large, make it a little bit bigger. Let's also give it some dummy text here. So this one is going to represent the number of moves that the user has done. So we'll start out with 0 moves. And then I'd like to add some padding onto this text view. So let me search for this attribute called padding. And let's give this text view a padding of 8 dp all around. So you can see how it created some space. Let me zoom in on the design preview just so we can get a closer look at the changes we're making. The last thing on this text view is I want to set the gravity of it to be center, which basically means out of all the space that we have, I want to be centered inside of the card view. So search for gravity, and then we are going to set the gravity to be center. You can see how it got centered in there. Now going back to the card view, one thing I want to add onto the card view is a margin. So we can see a separation between the card view and the background, which is the linear layout. So search for margin, and we are going to add a margin of 10 dp on all sides. So now you can start to actually see this card view take shape and have this elevation that I mentioned earlier. We actually want two different card views on the bottom in the linear layout. So what I'm going to do is I'm going to go over here, copy this, then go and select the linear layout and then paste it. What we did here is we are embedding two card views in the linear layout. And in order to make them show up side by side, there's a property on the elements in the linear layout called weight. And the weight dictates how much space should the linear layout allocate for this child. So if we set the value to be equal on each of the card views, that basically means we want an equal amount of space allocated. That looks good. So now in the text view on the right, we don't want that to represent the number of moves. We want that to represent how many pairs have been found. So I'll call this pairs, and then we'll say 0 out of 4. All right, and then you can see how one issue that we have right now is that the ID of these text views is identical. So let's go back into the code tab now and fix this. So you can see again here in the code tab, the red error highlighting. And one thing to keep in mind also is that any change that you make in the design tab, there's a one-to-one correspondence between that and what you see in the code tab. So you can kind of see here, we have a linear layout, and inside that linear layout is a card view with a text view inside, and then same thing down here. So we would like to change the ID of this one to be TV num moves, because it represents a text view with number of moves, and then the ID of this one should be TV num pairs. And then one more thing I want to do while we're in the code section is I would like to add a background color on the linear layout. I'm just going to add the background attribute, and the value of this I wanted to set to attribute, and there's one inbuilt called color secondary variant, which is kind of this teal color. And if we go in the design tab, you can see what that looks like. Cool, that looks pretty good. So now if we run the app, we should no longer be seeing the hello world text, and we should now be seeing this linear layout at the bottom with that hard-coded text that we have. Awesome. Next, we're going to drag out a recycler view, and this is going to be the primary component which will hold on to all the cards in our memory game. And I want to set the left and right constraints of this to be 0 dp, so I want to take up the whole screen width. The top constraint should be flush against the top of the screen, and the bottom constraint, I want this to be actually up against the top of the linear layout at the bottom. In order to have that take a visible effect, we need to change the layout height to be 0 dp. And now you can see how the recycler view is basically taking up all the remaining space after we've allocated the space for the linear layout at the bottom of the screen. And also the layout width, we can also make it match constraint 0 dp because we've properly defined the constraints on the left and right side. And this recycler view won't have any visible UI change because we haven't actually written the logic to populate it yet. That's what we'll do in the next part. The last thing I want to do to wrap up this part though is go back into main activity, and let's actually grab references to each of the views that we have on the screen now. So in particular, I would like to be able to get references to any of the components that we have that we will need to change programmatically. So in particular, these two text views and the recycler view. So give this an ID name of RV board, because it represents our memory board. Tap on refactor. TV num moves looks good, TV num pairs looks good, and let's just go ahead and change the default name of the ID here of linear layout 2 and make this LL game info, which stands for linear layout game info, because this is a container with all of the information of the game. And then let's refactor, and Android Studio will take care of updating anywhere else that this ID is referenced. So now in main activity, the pattern here is any widget that we have in our layout, we can reference in main activity, and we'll define that as a private member variable. And all these will be private late init var. So for example, RV board, and this is going to be of type recycler view. And then similarly, we're going to have one for TV num moves. This is going to be a text view. And there's going to be one more, which is TV num pairs. And that's also a text view. And the reason it's a late init var is because we know that these variables will be set, but they'll be set in the onCreate method, which is invoked by the Android system. They're not going to be created at the time of construction of the main activity. And that's why this is a late initialization. So now in the onCreate, as soon as we've called setContentView, now we can set these newly defined variables equal to the corresponding view in the layout. And we'll do that by calling a special method findViewById and provide the ID that we assigned. So for the recycler view, we give it an ID of RV board. And similarly, TV num moves. And then finally, TV num pairs. Now we've set up the scaffolding for the main activity, and we have references to the key views on the layout. The goal in the next part is to add in data to the recycler view in a 4x2 grid of memory cards that we'll define. So we have now this linear layout at the bottom, which shows information about the current game, And we have this empty recycler view, which takes up all the remaining space. Our goal for this part is to fill up that recycler view with a grid of icons, which will eventually be each memory card that you can tap on and flip over. But for now, we're just going to put in some dummy icon. And the interesting thing here is that the size of each of these cards that you're seeing are not hard-coded. Instead, we're going to dynamically set the width and height according to how much space we have. So on a larger phone or on a tablet, these will appear bigger. On a smaller phone, we're going to reduce the size appropriately. We're going to make them just large enough that we can fill up the entire space that we're given in this recycler view. Okay, so jumping back into the code, every recycler view has two core components. One is the adapter and one is the layout manager. Given some views that should be shown in the recycler view, the layout manager is responsible for measuring and positioning those items. So the layout manager is actually quite simple for us. We're going to use a predefined layout manager that comes with Android called the grid layout manager. And this is how we're going to have this nice grid effect. So this takes in two parameters, one which is a context. So we're passing in this, which is referencing the main activity, because the main activity is an example of a context. And the second parameter here is the span count, otherwise known as how many columns are in your recycler view. So for now, we're going to hard code this 4x2 grid. So there's going to be two columns, and each column is going to have 4 rows. We're going to pass in 2 here. And then later on, we're going to have to make this dynamic based on what the user has picked. The other component that we're going to define for the recycler view is an adapter. The adapter is more involved than the layout manager because it's responsible for taking in the underlying data set of the recycler view and turning that into or adapting each piece of data into a view. I'm going to set this adapter property on the recycler view, and we're going to define a new class which has all the logic for the adapter called memory board adapter. And this will take in 2 parameters, one which is the context, so I'm going to pass in this, and second will be how many elements total are in our grid. And we're going to hard code this in as 8 for now, and we'll change that later on. Before we define this memory board adapter, there's one more thing that I want to point out, which is optional, but it's a performance optimization, which is that there's a method on the recycler view called setHasFixedSize, and we're going to pass in true here. And what this method does, if you look at the documentation, is that we know the size of the recycler view is not affected by the adapter contents. So like we talked about earlier, the size of the recycler view on the screen is always going to be defined as soon as the app boots up. And it won't change regardless of how many memory cards are inside the recycler view. And so by setting hasFixedSize to be true, we can make our application a bit more efficient. Okay, so now let's go back and you can see how Android Studio is complaining that this class isn't defined. So let's have Android Studio help us to define this class. So tap on the red light bulb and tap on Create Class Memory Board Adapter. And we're going to extract this out into a separate file in the same package name. Okay, so the first parameter is going to actually be a context, not an activity. And the second constructor parameter will be num pieces, representing how many memory cards there are. And that will be an integer. Then hit tab one more time. One thing I want to do is I want to prefix each of these constructor parameters with private val, and that will actually allow us to use this in the body of our class. So what we have here is a class, memory board adapter, which is a subclass of the RecyclerView adapter class. And you'll notice that this is parameterized by something called RecyclerView.viewHolder. So a view holder is an object which provides access to all the views of one RecyclerView element. And so in our case, that will represent one memory piece or one memory card in the game. And we're going to define our own view holder, which will encapsulate that memory card view. And so what I'm going to do is I'm going to actually define an inner class here called viewHolder. And this is going to inherit from the RecyclerView viewHolder. Hit this red light bulb, and then we need to match the constructor invocation of the viewHolder. And now that we've defined this viewHolder, instead of being parameterized by the base class, I want to be parameterized by this inner class that we just defined. So we'll need to import that. Okay, and now that we've defined the inner class and we're parameterized by that, now hit this red light bulb that Android Studio is complaining about for the memory board adapter and implement the members. The RecyclerView adapter class is an abstract class, which means that we have several methods that we need to override in order for it to function. And there are 3 that we need to override. I'm going to select all 3 and tap on OK. And my preference is to have the inner class show up at the bottom of the class. So I'm going to have that, I'm going to move that down here. And now there are 3 methods here. onCreateViewHolder is responsible for figuring out how to create one view of our recycler view. getItemCount is actually really easy, so I'm going to define that right now, which is how many elements are in our recycler view, and that will simply be the constructor parameter that we passed in, num pieces. And then onBindViewHolder is responsible for taking the data, which is at this position, and binding it to this view holder, which is passed in here. So we'll come to that in a little bit. But first, let's define the onCreateViewHolder method. So the pattern here typically is we're going to use the layout inflator. We're going to create it from the context, which is the parameter that we passed into the constructor. And we're going to inflate a resource file which defines our layout. With r.layout.memory_card. And this takes in 2 more parameters, one which is the view group, the root view group, and that'll be the parent, which is the parameter passed in. And then the 3rd parameter is attached to root. We're going to pass in false here. We have to now define this layout file. Again, Android Studio will help us with this. Create layout resource file. Have the root element of this be a linear layout. Tap on OK. The objective here is to add in some children elements on this linear layout such that we create the view for one individual memory card in our game. So if I go into the design tab, what we'll do is, first off, let's change the height of this linear layout to be wrap content. Let's drag in a card view. And inside the card view will be an image button. We'll drag out an image button. And let's have the underlying drawable or icon behind that image button be this IC launcher background, which is this green grid. You should have that already from the default Android Studio project. Tap on OK. Let's have the ID simply be image button and have the width and height be match parent. So now you can see how it takes up the full dimensions of the card view, which is the parent. Let's set the background to be white, just a solid white color. And the scale type can be center crop. Cool. And the card view represents one actual memory card. So there's a couple design tweaks I want to do here. First off, I want to hard code the width and height to be 120 dp, just to give it a more realistic feel of what a memory card might actually look like. We're going to change this to be dynamically measured later on, but for now, 120 is a pretty good default. Let's change the card corner radius and height to be 8 dp, so it stands out a bit more. And let's also give this an ID of card view. Finally, the last thing I want to do is set the gravity of this parent linear layout to be center, so that this card view goes into the center of the screen. So search for gravity and then hit center. All right, awesome. So you can see how we're now aligned to the center of the screen. So going back into the memory board adapter, now this error went away, and the return value of layout inflator inflate will be the actual view which was created. I'll say val view, and then what we want to return here is the view wrapped inside of a view holder. And then in onBindViewHolder, what I want to do is, for now, just call holder.bind position. And bind is something which is not yet defined because Android Studio is looking for this method to be defined on the view holder class. It doesn't exist yet, so Android Studio will help us to create it. And for now, this is going to be a no-op. And then later on, we'll come back and address this. Okay, let's run the app and see what happens. Awesome. So what you can see here is we are now getting 8 different elements in our recycler view in this grid, 4x2 grid, and you can kind of see the outlines of the different cards that we've laid out. So what you can see here is that we're not really making a good use of all the space that we've allocated for the recycler view, right? Like we have this kind of awkward white space at the bottom. And also we want to ideally have some margin between each of the memory cards in our recycler view. So let's figure out how to do that. The first thing that's worth pointing out is that the space allocated for each memory card will depend on how many memory cards we have. So right now we have this 4x2 grid. which means we have 2 cards across and 4 cards tall. On the other hand, if we have a slightly larger board where we have 3 cards across and 4 cards tall, now we have 12 cards instead of 8. That means that the amount of width allocated for each memory card is going to shrink. So let's implement that first. Going back into the code, we need to measure what is the width and height of the recycler view, which is containing all the memory cards, and based on that, change the width of our card view. So instead of having this be hard-coded to be 120 dp, we want to measure that according to the recycler view width and height. And that turns out not to be that difficult because the recycler view is actually the parent, which is passed in here. So if we wanted to figure out what is the width of the card, so I'll say val card width, then that will be the parent dot the width divided by however many columns we have in our grid. So in this example, because we're hard coding is 4x2 grid, the width will be divided by 2. And then similarly for the card height, we have 4 cards tall. So we're going to divide the height of the recycler view by 4. And we're going to mandate that each memory card in our game is going to be square. So we're going to take the smaller of the card width or card height. So I'll call it card side length. And that's going to be the minimum of card width and card height. And you might have to import min, which is coming from kotlin.math.min at the top here. So now we need to actually grab out the card view from the view that we've inflated and set the width and height of that card view to be card side length. The way we do that is we say view.findView by ID, pull out the card view, which we gave it an ID of card view. And we're going to get a reference to the layout params. And this is going to be equal to layout params, a variable that we define. And on these layout params, this is what will allow us to change the width and height. The width will be card side length, and the height will also be card side length. So let's try this one more time. And hopefully now we shouldn't have this awkward white space at the bottom. And you can see that that is fixed, right? So we are actually taking up the whole screen width and screen height. There's one more observation I want to make, which is that we don't actually want the card to take up the full dimensions of the space we allocate to it. So for example, if we're putting a memory card into this yellow square, we want to have some margin between the actual icon and the space around it. And the reason we want that is because if there's a neighboring card, we want to have some white space in between the two. And so that's the next thing I want to implement with you, which is how do we add some margin so that we're not always flush with the card next to us. And this also turns out not to be that difficult. We're going to define a constant, which is the margin size. I'm going to define that in a companion object. In Kotlin, companion objects are singletons where we'll define constants. We can access its members directly through the containing class. Think of companion objects similar to static variables in Java. Let's define a constant called margin size, and I'll set that equal to 10. That's what I found to be a reasonable distance between each memory card. So the card width, we actually want it to be reduced by the amount of margin on either side, to the right and left. And so I'm going to subtract 2 times the margin size. And similarly, we want to reduce the maximum allowable card height by the margin on the top and bottom. So we'll subtract 2 times the margin size again. Now we're measuring the dimensions of the card, taking into account the margin, but we actually need to set it when we grab the card view reference from the view. We have to cast the layout params as a special type of layout params called margin layout params. And once we've done that, now we should be able to set the margin on the layout params. So we'll say set margins, and we're going to set the margin size all around on all 4 sides. Let's try it. That's so much better. Now we have this nice white space margin between each memory card. One quick improvement I'd like to make here is adding some margin on the recycler view as a whole at the top and bottom. So going back into activity main, I'm going to add a 8 dp margin to the top and bottom, and let's just see if that looks a little bit better now. Great, I like that a lot more because it gives us some breathing room between the memory cards and the underlying parent view. Right now, when I tap on any of these elements, nothing actually happens. To wrap up this segment, I would like to actually register a click listener on each image button, which is what these are. So going back into the memory board adapter, inside of the view holder, when we bind the view holder, we're going to grab a reference to the image button, which is inside that card view. So the way we can do this is in the constructor of the view holder, I'm going to define the image button. So the ID we gave it was image button. And so here we want to actually set the image button click listener. I'm going to add a log statement here. Clicked on position, and then let's print out the position. So we need to define this tag, which we'll do in the companion object. And the convention that I use is the tag name is always the class name. So in this case, the class name is memory board adapter. And let's try this one more time. So we're going to run the application and also open up logcat. So I am going to filter out only for info level logs because we actually have this at info level. And I'm also going to look for logs from memory board adapter. So I started typing in memory. And now if we tap on an element, you can see, okay, we do see clicked on position 0. If I go down to here, that's position 2, position 4, and this last one is position 7, which makes sense because we have 8 cards from position 0 to position 7. Just one more thing before we wrap up this segment. If you notice, if we go to the ends of the recycler view and scroll up or down, we get these shadows, which are the material design way of indicating that we're at the end of this recycler view. There's no more content. In our app, it doesn't really make that much sense because we are mandating or guaranteeing that the content of the recycler view will be fit to the screen dimension. Because the content is never scrollable, we should never be seeing this visual indicator called edge effect. And so if we go back into activity main and then go to the recycler view and then search for this attribute called over scroll mode and set that to never. That should address that issue. So if we rerun the app, now when I scroll up or down, you can see that there is no shadow. The goal for the next part is to introduce the notion of a board size, so we don't have to keep hard coding in a 4x2 grid. And we'll create some icons that the user will eventually pair up as part of the memory game. Now we have this hard-coded 4x2 grid of 8 memory cards. The first thing I want to do in this segment is create some flexibility so we can easily increase or decrease the number of memory cards in our game. And the second thing I want to do is create a bunch of vector icons, which will be used as the default icons when we play a new memory game. So first off, in order to build in more flexibility into the dimensions of our memory game, there's a couple things we need to adjust. So first off, right now, we are passing in 2 and 4 here as the dimensions of the board, which is incorrect. That'll change depending on how many cards are in a memory game. And second, we also are passing in 2 here for the span count, which is how many columns are in our board. And that also might change. And so in order to encode all the different information about the size of the board, I'm actually going to create an enum called BoardSize. And so if you open up the directory where main activity is located, I'm going to create a new package here, a new package called models. And we're going to add to this later on with a couple other things. But for now, the only thing this will have is a Kotlin file called BoardSize. And this is going to be an enum. And an enum can optionally take in a value. And so we're going to pass in a val here called numcards. This is going to be an int. So in our current example, what we have now numcards would be 8 because it's 4x2. We're going to have 3 different values of board size. First is easy. Second is medium. And that'll be 18 cards. And then lastly is hard, which is 24 cards. And these are the different options for the memory game. So the current version that we're playing is easy, there's only 8 cards, medium is 18, and hard is 24. We also want to encode in this enum information about the width and height corresponding to each board. And so I'm going to define a couple other methods here. One is called getWidth. It's going to return an int. And depending on the value of the enum, I would like to be able to figure out what is the width of the game. And so the way we can do this is say return using the when construct. This is referring to the board size on which we're operating, easy, medium, or hard. And the when expression is similar to a switch statement. So it'll evaluate a list of conditions and it'll return when the first one is met. So we're going to have Android Studio help us to create all the remaining branches. And what that did is create a branch for each of the 3 enum values. And so in the case of easy, the number of cards width-wise is going to be 2. In the medium case, we're going to have a 6x3 board. So we'll have 3 cards wide. And in the hard case, we're going to have 4 cards wide. It'll be 6x4. We're also going to have one method here, which is getHeight. And one thing to observe is that the height is fully determined once we know the number of cards and the width, right? And so the value here is simply going to be the number of cards divided by getWidth. And finally, there's one more method I want to add in here called getNumPairs. This is also going to return int. And this method is going to represent how many pairs of cards are there, right? So if we have 8 memory cards in our game, that means we're going to have 4 unique pairs. And so this is simply going to be the number of cards divided by 2. Okay, awesome. So now back in main activity, instead of hard coding in 8, let's define a variable up here called private var BoardSize. This is of type of our enum that we defined. And initially the value is going to be BoardSize.easy. And I would like the memory board adapter to take in the board size instead of the number of pieces. And then the grid layout manager, the second parameter is how many columns are there. And that'll simply be BoardSize.getWidth. Now let's fix up the adapter. And the second parameter should be of type board size instead of the int. So I'm going to tap this red light bulb and change the parameter to be board size. So going back into memory board adapter, let's change the variable name to reflect that. And now that we have this, we can update getItemCount to be BoardSize.numCards. That's the total number of elements in our memory game. And then the final thing we need to do is update what we're dividing the width and height by. And this is going to be the width divided by the board size getWidth, and the height we're going to divide by how many elements tall is our board. Let's try it. From the UI perspective, this should be identical, and you can see it is. But the benefit of what we did is we can now very easily adjust the size of the board, for example, making it hard. And now we should expect to see a 6x4 grid instead of a 4x2. And you can see that that actually happened. And the dimensions and spacing of these memory cards is looking good. Awesome. So the next thing I want to do in this segment is create icons, which will be the actual underlying image for each of these cards. And this luckily turns out to be really easy because Android Studio has a really nice way to do this. Open up the res directory, which stands for resources, and right click on drawable and go to new and tap on vector asset. If you look at clip art here, Android Studio comes bundled in with all of these free open source icons that we can use. And this is what we're going to be using to power the default version of our memory game. So for example, why don't we start by creating one icon, which is the face. So just search for face and we have this nice clip art. And I want to change the color of this to be red. So red is 25500. Choose that, and then let's also rename this to be IC face. Tap on next, and then this is just telling us that it'll be located inside of the drawable directory, IC_face, and tap on finish. Let's peek inside the created file. And one of the things that amazed me when I first learned about vector graphics is that the file is simply XML data, which describes the set of points, lines, and curves along with associated color information. So the image that we're seeing on the right is completely described by the text in the XML file. And so the really nice thing about these vector assets is that they're much, much smaller compared to a JPEG or PNG file where you have to encode information about all these different pixels, and there could be thousands of pixels in your image. And the other nice thing about this is that these are infinitely scalable. So because we're just defining the path data here, whether the image is 100 by 100 or 1000 by 1000, this image will always be crystal clear. So that's a really nice thing about these vector assets. And so if we look back to the board size, the maximum size of our board is 24. And that means we need to create 12 unique icons for our memory game. So right now we have one, we're going to create 11 more. So let me explain the logic behind how I created the vector icons, and you can do something similar. So you're free to choose whatever icons you want in order to build your memory game, but I did some thinking about it, and there are two things that we would like to optimize for as we pick our icons. One is that the vector icons that we create should be distinct shapes, and second, they should be distinct colors. And the idea here is that when you're playing memory, you want to have each unique image be as distinct as possible. So the shapes will come simply because we're choosing different icons. The colors are a bit more interesting. So as we think about what colors to make our icons, each color is represented as a red, green, blue component. And each of these three components is an integer between 0 and 255. If you wanted to create as distinct colors as possible, the way you would do this is try and have the distance between each color as per the RGB value be as different as possible. So the first thing that comes to mind is, why don't we light up or maximize each individual component? And that's how we get a solid red, solid green, and solid blue, just by having each of the three components be 255. We can also do something like this, where we go halfway on each. So you have 12800, and that becomes a little bit of a darker red. And similarly for this dark green and this dark blue. For the other 6 colors, we can combine each of these 3 primary colors. So we can make yellow by combining red and green. And then I picked a couple others as well that you're welcome to copy from me as well. So combining these colors with different icons that we picked, here's what I came up with. On the left is what I'll name each icon: icy face, flower, gift, and so on. The second column indicates the name of this icon in the Vector Asset Studio, so you can find it. And the third column shows you what the icon will look like with the selected color. Now let's go create these in Android Studio. Let's repeat the process for creating the face icon several more times. So we'll right-click on Drawable, go to New, and go to Vector Asset. The next asset we'll create is the flower. Local Florist is the name. And we'll change the name in our project to be Icy Flower, and we'll change the color to be green. Tap on Finish. And now I'm going to speed through this for the other 10 icons. All right, done. Now we have these 12 different icons. The next step is to reference them in Kotlin code so we can start to use them in our memory game. So the way I'm going to do this is I'm going to create a new package called utils. And inside of the utils is going to be a Kotlin file called constants. And we're going to now define a list of these drawables that we just created. So I'll call this default icons. And it's going to be a list of all the different drawables. So icy face. Then we have to import resources. And similarly for the other 11 icons that we created, I'm just going to reference all of them by saying r.drawable. The name of the icon. Now we have this list variable called default icons, which will be the icons we use in our memory game. Let's go back now into the main activity. Let me exit out a couple of these files. And what we would like to do is pass into the adapter the list of image icons, these drawables, that should make up that game. So we're going to end up adding one more parameter here. The way we'll do this is grab the default icons that we just defined. I'm going to randomize that list, and then we're going to take a certain number. And the number of images that we take will be BoardSize.getNumPairs. And the reason we want to do this is because, for example, in the 8-card memory game, we're going to have 4 distinct images, right? It'll be the number of cards divided by 2, which is what we're doing in getNumPairs. So we're going to take 4 images out of the default icons. So this is going to return to us the set of chosen images for our memory game. And now what we want to do is we want to double up those images. So we'll end up with 2 copies of each image. It will say randomized images is equal to chosen images, double it up. So we have each image in there twice. And we want to randomize that list by again calling .shuffled. And now this randomized images list is what we're going to pass into the adapter. So tap on that red light bulb and add the randomized images as a parameter. Tap on refactor. And then now let's go into the definition of memory board adapter. And I'm going to rename this to be card images. It's going to be a list of int. These integers represent one of these drawable resources. So now we can actually start to reference this inside of bind. So what we want to do is, based on the position, we want to grab the corresponding image, and that should be the image on the image button. So they set image resource, and that'll be card images. Oops, we have to actually make this card images a private val so we can reference it. So now go back here, card images, and position. Let's try it. And it looks like we have a build error here. I need to add in the closing bracket. Let's try it again. This succeeded. So right now, you'll remember in mainActivity.Kotlin, we're hard coding in the board size of hard, which means we have 24 memory cards in the game. And you can see that all the vector icons that we created are in this board, and there are exactly 2 copies of each. And because we're randomizing it, if I run this application again, we should see that these images are in different places. So right now we have this graduation cap, the school icon in the top left. Let's run this again, and hopefully that should be in a different position now. So you can see it is. And then if we also go back into the easy version of the board, run this, now we should be randomly picking 4 images out of the 12 that we have. And there should be 2 copies of each placed randomly among the 8 positions. And if we run the app again, we should have chosen different images, and they should be in different positions, which we are seeing here. Awesome. So now we have this well-defined board size concept along with a set of icons to play the game. In the next part, we'll start implementing the game logic. The goal for this segment is to lay the groundwork for the memory game logic that we'll write. And the key observation here is that every memory card will have an associated state. So for example, a memory card can either be face up, which means that the image is showing, or it can be face down, which is the default state in how the game starts. And so in order to capture all of that, we're going to create a data class in Kotlin representing one memory card. So open up the project tool window, and inside of the models directory, let's create a new Kotlin file called memory card. This is going to be a data class. And the objective here is we want to list out every attribute of a memory card. So first off, we're going to capture the idea of an identifier for the card. This represents the uniqueness of the memory icon, which is the underlying resource ID integer of the memory card. And this is going to be of type int because the actual identifier is going to be a drawable resource that we defined earlier. The second attribute of a memory card is whether it's face up or face down. So we're going to define another attribute called isFaceUp, which will be a Boolean, and this will initially be false because everything will start out, all memory cards will start out face down. There's an important distinction here of val versus var. A val is something which, once it's set, the value of it can't be changed, whereas var means that the value can be changed. During the course of a memory game, we'll be flipping cards over, which means that the isFaceUp property will change over time, and therefore it has to be a var. On the other hand, the memory card identifier will never change once it's set, so that's why we made that a val. There's one more attribute of the memory card, which is isMatched, and that represents if this memory card has found its corresponding pair. And as you play the game, you're going to be matching up cards, and when you've matched everything up, you've won the game. And so this is also going to be a var, isMatched, and it'll be a Boolean with initial value of false. Okay, so now that we have this data class in mainActivity.Kotlin, each randomized image that we have, this list of images that make up the memory game, each of those will correspond to one memory card. And I want to create a list of these memory cards. And the way we'll do that is we're going to utilize the map function on randomized images. And what that does is for every element of randomized images, we're going to do an operation and create a new list. We're going to transform randomized images into a new list. In particular, create a new memory card object. We're going to call the constructor memory card. This takes in 3 parameters that we just defined. First is the identifier, and that will be the current randomized image that we're mapping over, and we refer to that as IT. And then there are two more parameters here. One which is face up, and third is matched. Because we define a default value for is face up and is matched, we actually don't need to specify it here. So this can be as simple as randomized images.map memory card of it. And this is now going to return to us a list of memory cards. And instead of passing in the list of randomized images, I instead will want to pass in the list of memory cards. So let's update the third parameter of the adapter to be of type memory card. Let's go into the adapter and change this to be just cards. Now we can actually start doing something interesting with setting the image resource. By default, the image resource should be face down. It should be the default image. And only if the card is face up do we want to show the corresponding image. And so here what we're going to do is grab the card at that position and check, is it face up or not? And if it is face up, then we want to show the drawable image. So we'll call cards position and then pass in the identifier. And otherwise, we want to pass in the default icon, which is the face down. And that will be r.drawable.ic launcher background. And one thing we can do just to make this a little bit cleaner is save the variable of cards position into a local variable. So what we're saying here is that if the memory card is face up, then we will use that as the image. Otherwise, we'll use the background. So if we try this now, we should see a change such that all the cards are face down initially. And the next step is when we actually tap on one of these, we would like to be able to toggle or switch the value of this property is face up. Before doing that, one more thing I'd like to do is have a separate class which will encapsulate all the logic for the memory game. So right now we have a data class which represents one memory card, but there's also a notion of the game itself has some state, and we would like to be able to maintain that in a class as well. And so we're going to again go back into the same directory which has memory card, the models class, and let's define a new Kotlin file called memory game. And this memory game is going to take in the board size, and we want to delegate responsibility of creating all the cards into the memory game. That shouldn't happen in the main activity, that should actually happen inside of the memory game. And so let's add in as a constructor the board size here. The cards are going to be a member variable in this class. We're also going to have a couple more which we're going to add over time, but to start out with, we're going to have one which is num pairs found. And this is going to be 0. When you start out the game, you have found no pairs. In the constructor of the memory game, we're going to do the work to populate these list of memory cards. I'm going to add this in the init block. And the work we're going to do here is exactly the work that we already did over here. So I'm going to copy all this. The idea is that we are constructing the list of cards based on the board size. We are picking some random images, and then based on that, creating a memory card data class. So now all we need to do is construct our memory game. And the third parameter of memory board adapter should be the list of cards, which we can now get a reference to using the cards property of the game. Awesome. So again, there's no functional change here. All we're doing is kind of moving some code around so it's cleaner to understand where we'll add logic in the future. The last thing I want to do is changing the state of a memory card when we tap on it. Going into the memory board adapter, here is where we are getting notified of a click on an image button. And we would like to notify the main activity of this click, so then the main activity can then tell the memory game class that the user has taken some action, and we should update the state appropriately. And so the standard pattern for doing this is to define an interface. So let's do that up here. It'll be interface card click listener. And this is going to have one method called onCardClicked. And it's going to take in a position which is of type int. And the reason why we're defining this interface is because whoever constructs the memory board adapter, it will be their responsibility to now pass in an instance of this interface. And so we're going to add one more variable in the constructor called card click listener. And this is of type card click listener. And now when an image is clicked, we are going to invoke this method on the interface. So I'll say card click listener dot on card clicked with this position. Well, and so now back in the main activity, we're going to get an error right here because we haven't passed in card click listener object. And the way we'll do that is by writing the word object and specifying we want to create an anonymous class which is of type card click listener. And here Android Studio can help us with this red underline under object. Android Studio tells us, hey, this is an interface, so in order to implement this, you have to override this one method on card clicked. And so now here is where we can add the logic for toggling the is face up property of this card. So for now, I'm just going to put a log statement here just to make sure that we are able to actually get notified of the card click back in main activity. And then we need to define a tag for this. Let's do that. All right, let's run it. So we're not expecting any functional change, but now if we open up logcat, so now we're seeing 2 log messages every time we click on one of the cards. The first one is coming from the memory board adapter, and the second one is main activity being notified of this card click at the same position. So in the next segment, we're actually going to write the game logic for being able to flip over the card and also create matches. Our goal now is to implement the logic for the memory game. So when I tap on a memory card, I should be able to flip it over. And also there should be some logic to check if 2 cards that are flipped over are matched. This is an interesting challenge, and you'll find that if you break it down case by case, the code actually becomes quite simple. So in mainActivity.Kotlin, we have a log statement here for when the card has been clicked. And so I'm going to delete that, and let's actually delegate the work of this into a method called update game with flip at this position. All right, and the idea here is that this method is responsible for updating the memory game with an attempted flip at this position. All right, and so we're going to just delegate the work here into the memory game. And so in order to reference memory game, I need to make this a property of the class. So create property memory game, and it'll be a late init var. So late init because we know that memory game is going to be initialized properly, but it will only happen on create. So that's why we're going to add this as late init. And then one other variable that I would like to make into a property is the adapter. So we're going to split the assignment and the declaration of the variable. And then we're going to define another variable, which is a property of the class called adapter. And this is of type memory board adapter. So now we can reference adapter from multiple methods and not just the onCreate method. So in the update game with flip, the memory game itself should be responsible for handling what happens in the state of the game when the memory card at this position is flipped. We're going to create a method on the memory game class called flipCard, and it'll take in an integer parameter called position. Android Studio will help us to create it. And then I'll put this down here. Here is the game logic that we're going to write. To start out with, just to make this simple, why don't we simply change the value of the is face up property of this card. So I'm going to grab the card at this position, save that into a variable called card, and then we're just going to say card.isFaceUp is the opposite of what it was. So if it was face down before, it's going to be face up. If it was face up, it's going to be face down because the user is flipping it over. And so once we've flipped the card, then we need to tell the RecyclerView adapter that the contents of what it's showing has changed. And so it should update itself. And the way you do that is you say adapter.notify dataset changed. Let's try it. So now if I tap on any of these, you can see that there's underlying image resource is shown. and I can go back and forth as well. So I can toggle between them. So now let's think a little bit more about what exactly should happen when the user attempts to flip over a card. So for example, if I restart the game, if I flip over this card, and let's just pick another one like this, the next card I flip over should automatically flip back to the default state, the two cards that are currently flipped over. And so the memory game has to have some state or some notion of which cards have been previously flipped over and which have not. And as soon as I flip over another card now, both of these should have gone back down to face down. And if you think a little bit more about this, it really comes down to exactly 3 cases. So first is there were 0 cards previously flipped over. Second is there was exactly 1 card previously flipped over. And the third valid case is there were 2 cards previously flipped over. This is the totality of what is possible in a valid memory game. You can never ever have 3 cards flipped over at once. So now let's go case by case and figure out how the memory game should be updated. When there were 0 cards previously flipped over, all we need to do is simply flip over that card. There's no need to flip over any other cards in the game, and there's no way a match could be found yet, because after this turn is over, only 1 card will be flipped over, but you need 2 in order to make a match. Moving on to the next case, if there was 1 card previously flipped over, we will always flip it over, but we also now want to check whether the 2 cards that are going to now be flipped over, if they match. And if they do match, we want to indicate to the user at the UI layer that the match has been found, and we no longer want to allow these cards to be selected or flipped over again. And finally, in the third case, when there were 2 cards previously flipped over, we first want to restore the cards and make them face down again. And then we want to take the card at this selected position that the user tapped on and flip that card over. So if you can understand these 3 cases, then the rest of the logic is pretty straightforward. And one thing I can do to make this even simpler is you'll notice that this case, when there are 0 cards flipped over or there are 2 cards flipped over, they're actually identical. And the reason is because I could just copy over the same statement, restore cards plus flip over selected card, into the first case. And the idea here is that if there were no cards flipped over previously, then this restore cards is essentially a no op, so it has no impact, and then we will flip over the selected card. And so we've reduced these 3 cases down into 2 cases. That means the only information we need to distinguish between these 2 cases is if there was 1 card previously flipped over, and in particular, the position of that 1 card, because we'll need that in order to check if the images match. This is the key insight. And so what we're going to do is have a variable here called private var index of single selected card. And the type of this variable will be a nullable int with initial value of null, because when you make a new memory game, there is no single selected card. So now we can actually start hooking this state up into the flip card method. So if the index of the single selected card is null, what does that mean? That means that there were either 0 cards previously flipped over, or there were 2 cards previously flipped over. So in this case, like we broke down here in the pseudocode, the first thing we want to do is restore the cards. And then the second thing we want to do is update the single selected card to be this flipped card, right? So we'll say index of single selected card is now equal to this position that was flipped over. So let's define this method, restore cards. And this turns out to be fairly easy. We'll just iterate through the list of all cards that we have. And we want to set the is face up to be false, which basically means turn everything back to the default state. There's one caveat here though, which is that if the card has been matched, then we don't want to do that, right? So we only want to set the card to be face up if the card is not matched. So I'm going to add exclamation mark here and say, okay, if the card is not matched, then restore it to its default state. Awesome. So in the else condition, this is when we have exactly 1 card previously flipped over. So now, as per our pseudocode, we need to flip over the card and then check if the images match. And so let's write that logic. Add a method here, check for match. And we're going to pass into this method 2 positions on the board, on the memory board. And the objective is that this function will return to us true or false on whether those 2 positions on the board are identical images or not. The first parameter will be index of single selected card, and the second will be position. And this is going to return to us whether we found a match or not. So let's define this method, check for match. So the first parameter can just be position 1, and the second can be position 2, and the return type will be a Boolean on whether a match is found or not. So if the card at position 1, if the identifier of that is not equal to the identifier at position 2, then we know that the user has picked incorrectly. These 2 cards are not a match. However, if these cards do match, then we need to update the state of those cards to be isMatched is equal to true, because now we found the pair. The user has found the pair, so we should set isMatched to be equal to true. And if this happens, we want to update this variable numPairsFound and increment it. And then let's return true. Wait, let's see, what is the issue happening here? So numPairsFound, we defined it as a val, and it actually should be a var, because that will change over time. Wait, and then there's one more error here saying that smartcast to int is impossible because index of selected card is a mutable property. In order to force this to be a non-null int, I can just use a double exclamation mark to tell the Kotlin compiler to not worry about this. And the last thing we need to do here is that if we get into the else branch, which means there was exactly 1 card previously flipped over, after the user has finished flipping the card, then there will no longer be exactly 1 card flipped over. And so we need to set index of single selected card to be null. And the reason I wanted to save this found match variable is I would like flip card to return to us a Boolean on whether a match was found or not. And so I'm going to define a variable up here called var found match. And this is initially going to be false. And then it might turn true when the user has flipped over 2 cards and we're checking the value. And then here we're going to return the value of found match. Before testing this out, one more thing I want to do is in the check for match method, if our logic is correct, we will now set the Boolean property isMatched when cards are indeed matched. And so back in the memory board adapter, we can use that information to update the UI appropriately. In the bind method, based on whether the memory card is matched or not, we will set the alpha property of the image button view. So the alpha value refers to the opacity, how visible is the image button. And so if the memory card is matched, we'll set it equal to a lower value, 0.4, in order to fade it out and make it less prominent. And the F here stands for float, which is a different kind of number compared to an integer. And in the else condition, we will set the value to 1.0, which is a default full bleed opacity. And one more thing we can do here is if the memory card is matched, then we can change the background of matched cards to be a little bit grayed out. And the way you can do that is I can say context compat dot get color state list context r dot color gray, and we're going to define what that is. Else null. So this is now going to be a color state list. And we're going to call this method viewCompat.setBackground tint list image button color state list. The idea here is that the set background tint list is a way to set a background or shading onto the image button. And so if the image is matched, we're going to have a gray background, which we create using context compat.getColor state list with the gray color. And that will be one more visual indication to the user that this card has been matched. So let's now define this color resource. So have Android Studio help me to create a color value resource, color gray. And the value is going to be this gray color, EO times 3. Tap on OK. And just to show you what that did, if we command click or control click on color gray, it added one more line into the color.xml with the color that we picked. All right, let's try it. And looks like we have an error here. Invalid color, and I think I just forgot the hash symbol here. All right, let's try this one more time. So I'm just going to flip over a card, flip over one more. And in this case, these cards don't match. So we don't apply the different UI effect of cards being matched. But now here's the real test. When I flip over a next card, both of these cards should go back to being flipped over. Let's see if that happens. Okay, awesome. So you can see that both of these did go back, and now we're flipping over exactly one card. So we're playing a valid game of memory now. Let's see if I can find a match. So here's a house, and the other house was here. So there you can see that we found a match, and that resulted in us having this gray background color applied to the button, and the alpha value goes down to 0.4. So this is a nice way of telling the user that these cards have been matched already. All right, we found one more match. And one more thing I want to try here now is both of these cards are flipped over. Let's say now I actually try to tap on this graduation cap one more time. So that's a little bit weird. It actually led to this memory card being flipped back to the state, and this one stays flipped over. The correct thing to do here is not allow the user to make this invalid move. Let's try this one more time. So if I click this card again, we're kind of in this bad state now where the user is able to tap on something which shouldn't be a valid move in memory. That is what we're going to handle in this update game with flip method. So here we need to do some error handling. There are two errors that can happen. One is if we've won the memory game, and second is if that memory card is already face up. So first, if we've won the game of memory, this is going to be a method defined on the memory class, on the memory game class. Then we want to return because this move isn't valid. So we want to maybe alert the user. And the other error case is if the card at that position is already face up. And then same thing. In that case, we want to tell the user that what they're trying to do is invalid and then return early. So let's define have one game. So this is pretty straightforward because we know how many pairs have been found. That's this variable here, num pairs found. So we know we've won the game when the number of pairs is exactly equal to the total number of pairs that should be in this board. So we'll say BoardSize.getNumPairs. Let's also define this isCardFaceUp method. And again, this is pretty straightforward. All we need to do here is grab the card at that position and check the value of isFaceUp. So in order to check if this actually worked, I would like to show some UI when either of these things happen. And the way we can do this is by using a snack bar. So a snack bar is an Android component which shows up at the bottom of the screen, and you can use it as a way to message to the user about something. So I'm going to say snackbar.make, and we need to pass in a view here, the root view. I'll call this CL root, and I'll define that in just a little bit. I'll say you already won. And then we need to find a length here, snackbar.lengthLong, and then show it. And then if the card is face up, then invalid. Here we need to define the root element on which this snack bar will be anchored, and that's pretty easy to do. All we want to do is go into the activity main, and this CL root is going to refer to the constraint layout, the very root element. So I'll give this an ID of CL root, go into main activity, and let's define that up here. It's subtype constraint layout, and then we need to add it right here. CL root is equal to find view by ID, r.id CL root. Okay, so hopefully the errors went away with the snack bar. Awesome. Let's try running this one more time. All right, I flip over a card. Let's try flipping over the card one more time. And you can see invalid move, which is great. So in an actual game of memory, you shouldn't be allowed to flip over the same card twice. So we have to flip over one more card after we flip this one over. Awesome. So if I do the same thing, that's invalid. And let's actually play the game. Okay, now we've won. So now at this point, we shouldn't be allowed to flip over any card, right? So if I tap on any card, you can see that we get that snack bar. You already won. So just to review, what we're doing here is in the update game with flip method, the user is attempting to flip a card at this position in the recycler view. And we're doing some error checking to begin with. And then down here, we are actually flipping over the card. And this flip card method returns a Boolean now. So I'm going to capture that. Let's put a log statement here indicating that we found a match. And let's also print out the number of pairs that the user has found so far. And that data will come from the property numPairsFound on the memory game. This is the core game logic for playing memory. So if you have any questions or you're confused about anything, drop a comment and I'm happy to help as much as possible. In the next part, we're going to update the text views at the bottom of the screen in order to show how the game is progressing. The last part was quite heavy because we were implementing the core game logic. Fortunately, this part is quite a bit easier because all we want to do is update the text views at the bottom of the screen to show the progress in the game. Let's start with the text view showing the number of pairs found. So right here, we are capturing the return value of memorygame.flipCard, and if that returns true, the user has successfully found a pair of matching memory cards. And so in that case, we would like to reference that text view, which is TV numpairs, and set the text attribute to show this higher number of pairs found. So we'll say memorygame.numpairsFound, and this is a value out of the total number of pairs, which is BoardSize.getNumPairs. And here also we can do one additional check. If the match is found, then there's a potential that the user has also won the game. And so we're going to check that. So if memorygame.haveOneGame, then in that case, we just want to show a message to the user. You won. Congratulations. One quick correction from before, if the user has made an invalid move by tapping on a card which is already face up, I want to make the snack bar length short instead of long. The second text view in the bottom is for the number of moves the user has made. If the user has gotten past the first two error checks, the user has made a valid card flip. And so right here, we want to update the text view showing how many moves the user has made. memorygame.getNumMoves. This method doesn't exist yet on the memory game class, so Android Studio can help us to create it. And this is going to return an int of how many moves the user has made. So the logic here is that as soon as I flip one card over, I haven't actually completed my move yet. My turn in the game, or my move, is only over after I've flipped over two cards. So the number of moves will be half the number of card flips. So we're going to define one more member variable or property on the class called numCardFlips. This property will be private because we don't need to expose this information outside of the memory game class, and a var because the number of card flips will change as the game is being played. We'll set it equal to 0 initially because in a new game, there are no cards flipped yet, and we'll increment this numCardFlips variable every time we get into the flip card method because we know at that point we have a valid card flip. Now we simply use this value to compute the number of moves, and we'll just do numCardFlips divided by 2. And notice here that we are going to be doing integer truncation. So if the number of card flips is 5, when we divide by 2, the result of that will be 2 because we're rounding down. And that makes sense because when I've made 5 card flips, I'm in the middle of my third move. I haven't yet completed it. And so we still want to show number of moves being 2. Let's try it. So now as we play our game, we should see both of these numbers go up. Okay, so I made 2 card flips and then this makes sense. Now I made one move. Okay, so now I made 2 moves because I flipped over 4 cards total. And I got lucky with this last one and I found a pair. So you can see how this also got incremented. Let's keep going. Awesome. So now we see the snack bar U1 and the total number of moves is reflected properly along with the number of pairs. The last thing I want to do in this segment is I would like to actually add in color interpolation on the number of pairs. And this is a nice visual way for the user to know, using a color, their progress in the game. So every time we increment the number of pairs, we want to also update the color of the text view. We'll say TV numpairs.set text color, and we're going to pass in a color here. And this color is going to be the result of interpolation. So interpolation is a fancy statistical term, but it's actually quite simple. If I tell you that I'm walking 1,000 steps and I'm 75% done, then you would probably tell me I should roughly have taken 750 steps. And what you're doing in your head is linear interpolation. At the starting point, I've done 0 steps. At the ending point, I've done 1,000 steps. And so when I say I've done 75% progress, you are estimating that I should be roughly 750 steps into that journey. We're doing something identical here. We're going to use a built-in class in Android called ARGB_evaluator, which will take in the worst color, meaning no progress has been made, 0 pairs have been found, and another color representing full progress has been made, which means the user has won the game and all the pairs have been found. And all we need to do then is provide progress of how many pairs have been found so far in the game. And based on that, we will do interpolation between the worst color and best color. And this is possible because, like we talked about earlier, colors are simply integer values behind the scenes. So here's how we can compute the fraction of what progress has been made so far. The number of pairs found divided by the total number of pairs. And the issue here is that it expects a float rather than an int. So we're going to cast the numerator as a float. The second and third parameter are the start and end value, representing no progress made and complete progress made. And so we're going to use context compat to get the color, and then we're going to have to actually define the color resource in our colors.xml file. I'll call the color resources color progress none and color progress full. So now we will create the color value resource, and what I put in here is this red color, because red kind of indicates to me that you've made no progress, you're stopped, so that's the worst value. And then for color progress full, I am using this green value, which means that you've made it. Green means go, so you've made a lot of progress and you've won the game. Awesome. And then this set text color requires an integer, and so we're going to now cast the value of this ARGB_evaluator as an int. Let's try it. As I make progress in this 8 memory card game, there are 4 pairs. Each time I should be 25% closer to hitting that green value. So after 1 pair, you can see the color changing a little bit. And now you can see the full green color at the very end when I've won the game. One thing you'll notice is that at the very beginning of the game, we should see the color of that text view be red to indicate no progress, but right now it's that default black color. So let's fix that. Inside of the onCreate method, after we've defined TV num pairs, let's set the text color of that text view to initially be the color representing no progress, color progress none, which is that red color. And if we try it, we can see that the text view color is indeed red. At this point, we're able to play a fully functional memory game along with having information at the bottom showing how the game is going. The goal for the next segment is to give the user some control to restart the game and also allow the user to control what size memory board they're playing with, easy, medium, or hard. The goal for this segment is to allow the user to restart the game that they're currently playing or to pick a new board size and try a different game. So let's start out by adding a menu option for restarting the current game. So let's go into project and go into resources, and we're going to create a new resource directory, Android resource directory, which is of type menu. Inside of this directory, we'll create a menu resource file called menu main. And let's start out with just one menu item. We'll give this menu option a title of refresh, but we'd actually like for this action to have an icon associated with it. So we'll create a new vector asset called refresh, give it a name of IC refresh, and then tap on finish. And we're going to set the icon attribute of this menu option to be this newly created icon. We'd like for this menu option to show up as an action rather than being buried by default inside of the overflow menu, which is what we're seeing here. So I'm going to hit the show as action attribute and hit always, which indicates to the Android system that we want this to be an icon rather than text in the 3-dot menu. Now we have to actually inflate this menu resource file that we just created in main activity. So there's a method we will override called onCreateOptions menu. So if you just start typing onCreateOptions menu, you should find it. And we are going to get the menu inflator and inflate the r.menu main. And the second parameter here is the menu, which is the parameter. And then we'll return true, because this method onCreateOptions menu requires a Boolean return value. Now we want to get notified when the user has tapped on that particular menu item. So first, going back into menu main, we want to add an ID. I'll call this MI refresh, which stands for menu item refresh. Copy that, and then the way we get notified of the user tapping on an option menu is through this method on options item selected. So here we'll use the when construct. So we'll say when item.item ID. So based on the item ID of this menu item, we'll take a different action. So the only one we have right now is r.id.mi_refresh. And in this scenario, we want to set up the game again. So setting up the game again basically entails doing all this logic again, where we create a new memory game, we set up a new adapter, and then we set up the recycler view with this new data. Let's push all of this logic into a separate function, which we can then easily reuse. So I'll call this setup board and paste in that logic in the newly created function. And then my preference is usually to put all of these private functions below all of the functions that we're overriding. I'm going to put this down here. Okay. Awesome. So now let's just simply call setup board right here. Let's try it. So hopefully now we should see a menu option up here where we can refresh. So let's just click a few of these. And then if I hit this option now, I should be able to refresh the whole game. Yep. And you can see that now we have different cards show up. Awesome. One thing that is worth doing though is that if I'm in the middle of a game like this, I've already made 3 moves and I already have found 1 pair, I'd like to warn the user that they're about to lose their progress on the game. And so right here, if the number of moves in the memory game, get num moves, if that's more than 0 and the user hasn't won the game yet, then we should be showing a alert dialog to the user, informing them that this is a dangerous operation because they might be very close to winning, but they accidentally hit the refresh button, for example. So I'm going to delegate that work of showing the alert dialog to a method because we're actually going to show several alert dialogs depending on which menu option the user taps on. So I'll say show alert dialog, and then create a function for this. We're going to leverage the alert dialog builder in order to create and show the dialog. It takes in a context. We'll pass in a title, which will be passed in as a parameter. Same thing with the view, and then we'll get to the negative and positive button click listener in a bit. But first, let's go back and add the title and view as parameters. Now we'll set the negative button text to be cancel. And by passing null here, we're basically saying just dismiss this alert dialog if the user taps on cancel. We're also going to add in a positive button, which will be OK. And here we need to actually take action based on the user tapping on the OK button. If we go into the declaration of set positive button, the second parameter is onClickListener, which is an interface which has 1 method. And that 1 method has 2 parameters, but neither of these is actually relevant to what we need to do here. So in order to indicate that we're still adhering to that signature, we're going to put in underscores to say that that's the method we're overriding. And this is where we now need to take the action based on what happens when the user taps on OK. And that has to be something that's passed in as a parameter to show alert dialog. So I'm going to add a third parameter here called positive button click listener, and that will be of type view.onClickListener. Now we can call the onClick method of the positive click listener, which takes in a parameter of view, which we don't care about, so we'll pass in null here. So now let's look at how we can use this. In the show alert dialog method, we'll pass in the title, which will be quit your current game. We don't need to show any additional information, so the view of the alert dialog can be null. And then we're going to pass in the positive button click listener, which is what should happen when the user confirms this alert dialog. And we're just going to call setup board. And in the else condition, the user is not in the middle of a game, so we can just unconditionally call setup board. So if I make some moves like this, and now I refresh, you can see that before setting up the game again, we had this dialog, which has the title that we specified along with 2 buttons, cancel or OK. So if I cancel, all we're doing is exiting the alert dialog, but we haven't actually taken any action, which is what we want. On the other hand, if I tap OK, now we are properly resetting the board, which is exactly what we want. One other issue that you'll notice is that we aren't resetting the value of these text views properly when we call setup board. So let's fix that. So go into the setup board method, So depending on the board size, we would like to reset the value of those text views at the bottom. So board size is an enum, and so now, because it's an enum, we know what are the possible values of this. So we'll have Android Studio help us to add the remaining else branches. In the easy case, we'll first set the TV num moves text view, and we'll set that to be equal to the current game being played, which will be easy, and that's a 4x2 grid, and the number of pairs is going to start at 0, and there are 4 pairs total. In the medium case, we'll describe that the board is 6x3, and the number of pairs total will be 9. And then finally, in the hard case, the board dimensions will be 6x4, and the number of pairs is 12, because there are 24 cards. So I'm making some moves. And so now if I reset, you can see the number of pairs has gone back to 0, and I also reset this back to a description of what game we're playing. Awesome. The next thing we want to do is add one more menu option, which will allow us to change the size. So right now, the only game we can play is easy, but I'd like to have one more menu option, which allows us to select easy, medium, or hard. So for that, let's add one more menu option in menu main. And this one, I want it to actually show up in the overflow menu. So I'm going to say show as action never. And the ID of this will be mi new size. Title will be choose new size. All right, so going back into main activity, in order to handle that menu item being clicked, in the on options item selected in the when expression, we'll add the ID and we'll create a function called show new size dialog. One thing I'll also do is add return true every time that we're handling the menu item clicked, both for the refresh and this one. So in this new function, show new size dialog, we're going to call that function, show alert dialog that we just created, and the title will be choose new size. We're going to pass in a view. I'll pass in null for now, but that should be a list of all the different options of board sizes. And then when the user taps on OK, we should change the value of the board size variable in the main activity. All right, so the objective here is that we want to create a new view which allows the user to pick between the various board sizes. And the way we're going to do this is have a radio group, and that radio group will have 3 radio buttons, easy, medium, hard, and that's how the user can specify which game they want to play. And so we're going to inflate that view, similar to what we did in the adapter, the context, which is this, and we want to inflate r.layout.dialog board size, and pass in null for the second parameter. And this is going to return to us a board size view. So now we have to define dialog board size. So hit that red light bulb and let's create a layout resource file. And then constraint layout is fine for the root element. Let's go into the design tab. I'd like to drag out a radio button group. Let's give the radio group an ID, a radio group. And let's also add some horizontal constraints. On the left side, it'll be 0 dp from the parent, and also on the right side. That means we can make the layout with 0 dp or match constraint. Now let's drag out 1, 2, 3 radio buttons. Let's give the first radio button an ID of RB easy, and then give it an updated text of easy 4x2 to describe the game. The second radio button can be RB medium, and the text will be medium, which is 6x3. And then the third radio button will be RB hard, and that will have a text of hard 6x4. In the component tree, you can see that red exclamation mark, which indicates error, and it says that there's a missing constraint on the radio group. So if I go into the radio group, we can see that it's actually not vertically constrained. So I'll add a 0 dp top margin from the radio group to the parent, and that should resolve that issue. One other thing I'll do is add a left and right margin of 16 dp and an 8 dp margin on the top, just so we can create some space between the radio group and the parent alert dialog. Okay, so now we have the dialog board size. So this view is fine. So now we want to figure out if the user taps on the OK button, then the code here will get executed. The value of the board size that we set in here will depend on which radio group button was selected. And so we need to first define that radio group. We need to pull it out of the board size view. So I'll do that now. And the radio group will mandate that only one of the buttons inside of it can be selected at a given time. So depending on which of those was selected, which is a checked radio button ID, we will set the board size accordingly. So we want to add in 3 IDs here, RB easy. And in that case, the board size should be easy. If the ID selected was medium, then the board size should be medium. And otherwise, the board size should be hard. One more thing before we try this out is when we open up the dialog, I want the current size board to be the one which is automatically selected in the dialog. So depending on the board size, we want to tell the radio group which item should be checked. So in the case of easy, then we want to check the RB easy. And once we have specified a new board size, then we simply call setup board. And that should take care of redrawing our whole board. Before running this, we need to actually pass in the board size view, which we constructed on 77, and pass it into the show alert dialog method. Let's run it and see what happens. Then we are able to see this radio button group, and we have the easy radio button selected because we were playing a 4x2 grid. Let's select medium and see how the recycler view gets updated to properly show the 18 cards. And let's also try out the hard version. So if we go to that dialog again, we see the medium is pre-selected, and hard shows us the 6x4 grid. And you can also see at the bottom, the game info is also correct. The last thing I want to do in this part is to update the color of the refresh icon because it's a little bit hard to see right now. So this icon is what we just created. It's called IC refresh. And the color of it is dictated by this attribute here called Android tint. So I'm going to replace that and just use FFF, which is white. And running the app again, we do see that the menu icon is now white. Now we are fully done building out the memory game played with the default icons. In the next part, we'll allow users to create their own custom memory games by taking photos from their phone and using that as the back of each memory card instead of these icons. In this segment, we're going to embark on the creation flow, where the user can create their own personalized memory game using photos from their phone. The idea is that each memory card, instead of having one of the default icons that we have put into the app, we're going to have each memory card be a photo that the user has picked out. So to start out with, we're going to just add one more menu option here, which will launch the creation flow. So I'm going to go into menu main. Let's check out one more menu item. And the title here will be create custom game. Let's give this an ID of MI custom, which stands for menu item custom. And then show as action will be never. We always want this to be underneath the 3 dots of the menu. So now that we have that, let's go into main activity. And here is where we can register some action to happen when the user taps on that menu item. So I'll say r.id.mi custom. And then we'll put this into a new function called show creation dialog. Let's define this, create function. And this creation dialog will actually be quite similar to show new size dialog, because the very first thing we want before we navigate the user to the creation flow is we need to understand what size of a memory game do they want to create. And so we're going to reuse the exact same dialog board size here and inflate that, and that will be what we show in a dialog before we allow the user to go into the creation flow. So I'm going to go ahead and just copy all of this. And now we are going to show the alert dialog. So I'm going to copy this now, although we're going to modify this a little bit. So the title of this alert dialog shouldn't be choose new size. It should be create your own memory board. Then the view will be the 3 different options of memory games. And here we would like to figure out which board size has been picked once they tap on the OK button. And so for that, that'll be a local variable called val desired board size. Board size. And we're not going to set up anything here. We want to navigate the user to a new screen. or a new activity where they can actually start choosing which photos they like. One thing I like to do before going forward is open up the dialog board size and have a default radio button selected. So we're going to choose the easy radio button. And what that means is by default, when the user is creating a new memory board, they're going to be creating an easy board, but they have the option to pick medium or hard if they want. Now our objective is to create a new screen or new activity when the user has tapped on the OK button of this alert dialog. So open up the same directory where main activity is located, right click on it and go to new activity, and we're going to choose empty activity and call this CreateActivity because this will be the screen for creating a new board. And then we'll just tap finish. So the way we navigate between activities or screens in Android is through something called the intent system. So intents are fundamental to Android. They're basically requests to the Android system or to another application to do some certain action. So the intent that we're doing here is an intent to go from the main activity and launch the create activity. So I'll say val intent is equal to intent. And there are two parameters in the intent constructor. The first is a context, which is we're going to pass in this, which is referring to where we're coming from. And the second parameter is the class that we want to navigate to. And that will be the CreateActivity.java. And now in order to actually navigate to the create activity, we need to call this method start activity. And there are two versions of the start activity method. One is start activity and the other is start activity for result. The start activity for result is necessary if you want to get some data back from the activity that you've launched. So in our case, we're going to be launching the create activity. The user will be creating a brand new board there. And then whenever that's done, we actually want to get that data back in the main activity and allow the user to play that custom game that they just created. And so we do want start activity for result because we want to get that signal back from our child activity about what is a newly created game. So I'll say start activity for result and pass in the intent that we just created. And because we're doing start activity for result, we also need to pass in a second parameter, which is the request code. So I'm going to define that as a constant called create request code. And we're going to have that be defined inside of the companion object of main activity. So say private const val create request code, and I'll set this equal to 248. It doesn't actually matter what this is as long as it's some unique integer within your activity. 248 is near and dear to my heart because that's the area code of where I grew up in Michigan. Let's test this out by running the app, and what we expect is when I tap on the menu option to create a new board and I confirm the alert dialog by picking a size, then I should be navigated to a new screen which should be empty. That should be the create activity. And we can see that it's an empty activity, and our goal now is to actually fill out the UI to allow the user to create this custom board. One piece of information that we need in order to properly show the create flow is what size board does the user want to create? What size game did they choose? And that's actually the data that we collected via the radio buttons, but we're not doing anything with that data. And so Android has a system with intents to pass additional data along with the request to do an action. So here we're making the request to start the create activity. Inside of that intent, we're going to put in an extra, and that will be the desired board size. So the extra has a key and value. The key is always a string, and the value is the variable that we want to pass between these activities. So the key I'm going to define as a constant, extra board size, and the value is going to be desired board size. So we have to define extra board size. I'm going to put this inside of the constants.kt file that we have from earlier. And this has to be a string. So I'm just going to have the string value be extra board size. Let's import this. And the reason I'm defining extra board size into a separate file as opposed to within main activity itself is because we're actually going to be referencing extra board size in create activity. And so for anything which is shared, a shared constant between multiple files, I'm going to put that into constants.kt rather than defining it into a single file. So now that we've added this, let's go into create activity and let's pull that data out from the intent. So the way this works is we will get the intent and get the serializable extra board size, and we're going to cast this as board size, right? And we're going to save that into a variable called board size. And actually I want this to be a member variable so we can reference it across multiple methods. say private late init var BoardSize. And now we don't need to declare it in the onCreate function. One more thing I want to do is, based on the BoardSize, I want to modify the title of the CreateActivity to indicate how many pictures does the user have to select from their phone in order to make a valid game. So the number of pictures the user has to select will be half of the number of cards in that game of memory. So for example, if I have a hard game that I picked, which is 24 cards, I need to pick 12 unique images from my phone. And so that's what I want to communicate in the title of this action bar. So in order to change the text, we can say support action bar dot title, and then this is going to complain because support action bar technically is nullable, and so we can use a question mark operator, which says only call this attribute if support action bar is not null. And if that's the case, then we want to set this equal to some string, and we're going to set this equal to choose picks 0 out of 12, for example. So if we pick the hardboard, it would be 12 here. If you pick medium, it would be 9, and so on. Of course, we can't hard code in 12 here, so I'm going to define another variable, which is num images required. So this will be a private var num images required, and initially this is going to be -1. But as soon as we get the intent extra, now we can set this equal to BoardSize.getNumPairs. And so now instead of hard coding in 12 here, I'm going to pass in num images required. And one more thing I want to do before we test this out is on the support action bar, there's an ability to, instead of having the default appearance, we can have a back button, which allows the user to easily exit out of this flow and go back to the main activity if they want. The way we can do this is say support action bar dot set display home as up enabled and pass in true here. That'll modify the action bar to show a back button. And then we need to actually take some action when the user has tapped on that back button. This is similar to what we have done before. So we're going to override this method on options item selected. I'll say if the item ID is equal to android.r.id.home, then we'll just say finish, which means I want to finish this activity and go back to the main activity. Return true here. And the reason this is android.r.id.home is because this ID is defined within the Android system, the Android SDK. This is not a menu item that we added, so that's why it has an Android prefix here. Let's try it. So we go into the creation flow. Let's pick easy. And so now you can see that we have the back button, and it says choose picks 0 of 4, which makes sense because there are going to be 8 images in the easy version of the game. So that means we have to pick 4 different pictures. If I tap on back, then we go back to the main activity. The last thing I want to do in this segment is do some quick adjustments into the UI in the activity create.xml. So right now it's just a blank screen. Let's give ourselves a bit more space. I'm going to minimize this, and also let's delete some of the extra files that we don't care about right now. So by default we have this constraint layout, which is the root element, and that's fine. What I want to do is I want to drag out a button, and this will be anchored to the bottom of the screen, and this is going to be how the user can save their newly created game. So I'm going to constrain it to the bottom and also to the right and left, and I want this to take up the whole screen width because it's a primary action. This is what the user really is intending to do when they come to this screen. Width will be match constraint, so it takes up the whole width, and then I'm going to have a 16 dp margin on the left and right. Let me zoom in and show you a little bit closer. And then also on the bottom, let's add an 8 dp margin from the bottom of the screen. Let's change the ID to be btn safe. And then let's also give this text of safe. One thing that we'll want to do is, by default, the user shouldn't be allowed to tap on this button because they haven't actually provided the correct data in order to create this game, right? Like, it doesn't make sense to save the game without having chosen some images, which we'll do later on. And so to start out with, search for this attribute called enabled, and then we're going to set this to be false. So that grays out that button. That looks good. And then one more widget I want to drag out is an edit text. And this edit text represents the name of this custom game that the user is creating. So I want this to also be full width. So drag this to the left and right, and have it also be 16 dp on the left and right side of the screen. And then I want it to be constrained to the top of the save button. Let's give it a margin of 8 dp from the bottom, and the width can be match constraint, so it takes up the whole screen width. Let's change the input type to just be text. We don't want this to be a person name, we just want it to be regular text. And by default, there should be no text here. That's for the user to fill out. But we do want to give the user a hint of what they should write in this edit text. So in the hint attribute, I'm going to write game name, example, panda fun. And just a few more things before we wrap up. First off, I would like to set an attribute called digits on this edit text. So search for digits. And what digits represents is what is the valid allowable input in this edit text. This game name that the user writes is going to be living in our database that we'll get to later. And so we want to constrain what the user is allowed to actually put in here. You can kind of copy what I did. I'm allowing the user to enter in any of the digits, 0 through 9, or A, B, C, D, all the lowercase letters, or underscore or dash. That's it. So there's no slashes allowed, no question mark, no period, things like that. And the reason for this is because I want it to be easy for people to be able to share the game name. So for example, panda_fun is a valid game name, and that's also easy for me to communicate out to someone else. As soon as we start introducing uppercase or lowercase letters or slashes or things like that, that will make it harder to communicate the game name to other people. And also it actually might cause some issues in our database. So it's better to constrain the user input here. A couple other things. I played around with this a little bit. I want to set the IME options to be done, action done. And what that'll do is it'll change the keyboard to have a check mark at the bottom right to indicate to the user that they've finished filling out this field. And we can also change the ID here to be ET game name. So it stands for edit text game name. And if we go into the code tab, there's one more change I want to make, which is called important for autofill. And we want to set this to no. And what this means is that we don't want the Android system to be overeager and autofill this field. And finally, specify the maximum number of lines allowed in this edit text, which will be 1. That basically means that there are no line breaks allowed in this edit text, which kind of makes sense. We want the game name to be short, concise, and fit onto a single line. Let's try it. So now when we navigate into the creation activity, then we expect to see this UI at the bottom of the screen. Awesome. So you can see the button is disabled and we have this edit text which has the hint that we specified, and I can type in A, B, C, D and the letters like that. But if I try typing in a question mark, you'll see that it doesn't actually show up. Same thing with capital letters or slash and so on. So that looks like it's working. Awesome. So we have the shell of the UI for our create activity. In the next segment, we're going to start fleshing this out a little bit more by allowing the user some UI where they can tap and select photos from their phone. The goal for this segment is to continue to flesh out the UI for the create activity. And in particular, we want to show a grid of gray boxes, which will be an indication to the user to tap on those in order to pick an image from their phone. And the way we'll do this is actually quite similar to what we've already done with the main activity. We're going to have a RecyclerView, which has a grid layout manager, and that'll be how we construct this grid of images, or grid of gray boxes for now. So the first thing I want to do is in the activity create, in the design tab, let's drag out a RecyclerView. Let me zoom out a little bit. So I want this RecyclerView to be constrained to the right end of the parent and left end of the parent. That's how we get 0 and 0 over here. Also constrained to the top of the parent. And the bottom should be actually constrained to the top of this edit text. And in order to have this to actually take an effect, we have to change the layout width and height to be match constraint. Awesome. So you can see how the RecyclerView now is taking up whatever is remaining after subtracting out these bottom components. Let's give this an ID of RV image picker. Now in the CreateActivity, the first thing I want to do is get a reference to the 3 views on the screen: the recycler view, the edit text, and the button. So all these will be late init var because we're going to declare them as member variables, but actually set the value in on create. So we'll just say RV image picker, find view by ID with the corresponding ID, and similar for the edit text and save button. Similar to the main activity, the recycler view will have 2 core components, the adapter and the layout manager. The layout manager is easier, so that'll be equal to the grid layout manager. We'll pass in the context, which is this, and the second parameter is the number of columns. That'll be the getWidth method on the board size. One thing we can also do here is similar to the main activity. I'm going to call this method setHasFixedWidth. Set is equal to true, because we are guaranteeing that the recycler view dimensions won't change because we've allocated just enough space for it. And now we want to set the adapter. So I'm going to say RVImagePicker.adapter, and we're going to set this equal to an image picker adapter, and this is the class that we're going to define. This will take in 3 parameters. First is a context, and then we are going to pass in a list of the images that the user has chosen. And so I'm going to define that as another variable up here. Call this private val chosen image URIs. There's going to be a mutable list of URI. So a URI, we'll have to import this, is a uniform resource identifier. You can kind of think of it like a string, which unambiguously identifies where does a particular resource live. And so the resource in our case is an image. This is an image which lives on the phone. It's physically stored on the phone. The URI is describing what is the directory path to locate this photo. So when the user has picked 2 or 3 photos, for example, there will be 2 or 3 elements in this list, 2 or 3 URIs. So that'll be the second parameter. And the third parameter will be the board size. Let's have Android Studio help us to create this class. We'll extract it to a separate file. And the first parameter, I'll rename it to be context, so private val context. Second parameter is the chosen image URIs, and I want this to be just a normal list and not a mutable list. And the third parameter is the board size. And all of these should be private val. Just like before, we would like to define an inner class view holder, and that will be what we parameterize the constructor of the image picker adapter by. So I'll define inner class view holder, which inherits from RecyclerView view holder. And once we've defined this inner class, now we can go ahead and override the 3 members or 3 methods of the adapter. Okay, so the get item count is straightforward. The number of images that the user has to pick is the number of pairs in this game. So if I have a 24 card memory game, then the user has to pick 12 images, and we should be returning 12 here. So that'll be board size dot get num pairs. That's why we passed in the board size as a constructor parameter. And now let's implement the onCreate view holder. So again, this is going to be quite similar to what we already did in the memory board adapter. So I'm going to call layoutinflator.from, pass in the context, which is a constructor parameter. And we're going to inflate a custom layout file that we'll define. I'll call it card image, parent, and false. All right, this is going to be a view, and let's now define this card image resource file. I'm going to have the root element here be a linear layout because we can keep this file a little bit simpler. And this is going to be really straightforward. There's no need to embellish the design with any kind of card elevation or rounded edges or anything like that. So the only thing we need to do is drag out an image view. Cool. And so I want to just hard code the width and height just to make this look a little bit more realistic, to be 100 dp each. Give this an ID of IV custom image. And let's change the scale type to be center crop, just like we had done earlier. And let's also provide some margin on this element, just so that the card views that we show in the creation in the create activity aren't glued next to each other. There's going to be some space in between them. So I'll search for margin here and set this equal to 8 dp. Cool. One more thing is that the parent element, the linear layout, I want the height of this to be wrap content. And then finally, we want the image view inside of the linear layout to be centered. So we're going to set the gravity of the linear layout to be center. And one more thing we can do here also is on the image view, if there is no image selected, which will be the default state, then I want to set the background color of the image view. And we're just going to have this be a hard-coded color, which is coming from the Android system called darker gray. And you can't see that in the preview because we are using this sample image, but you'll see it when we run the app. So going back to the image picker adapter, now we have this proper card image that we're inflating. And similar to what we did last time, this image view, it shouldn't have a hard-coded height of 100 dp. We should instead be making proper use of the space of the screen. And so we're going to do something quite similar. So I'm going to look at the width of the parent, which is the recycler view. How much space have we allocated for the recycler view? And I want to partition that up into however many images the user should pick across. So that's will be BoardSize.getWidth. That will be the card width. And then the card height, the maximum allowable card height will be the height divided by the number of rows in our board, which is BoardSize.getHeight. And again, similar to last time, we're going to define a card side length, which is the minimum value of the card width and the card height. So we're going to have to import math.min from Kotlin. And so now we can grab a reference to this image by using the ID. So I'll say view, which is the linear layout plus the image view. And then inside of that view, we're going to find the image view with this particular ID, r.id.ivCustomImage. We're going to get the layout parameters. And on the layout parameters, now we can set the width and height to be the card side length that we just computed. And finally, the return value of this onCreateView holder is a view holder. So we are going to construct this new view holder class and pass in the view that we inflated. We can actually make this card height a val just because we're not changing any of these again. So similar to the view, card width, card height, because these values are not changing, we can set all these to be val. And finally, the onBind view holder method. So the intention here is, given a particular position, we want to define how do we display the UI. There are two cases here. So if you think back to the second constructor parameter, the list of image URIs, so let me actually rename this to be just image URIs. So if the position that we're binding here is less than the size of the image URIs, that means that the user has actually picked an image for this position, and we should show that image. On the other hand, if the position is larger than image URIs, the size of image URIs, that means that we should just show the default kind of gray background to indicate to the user that they still need to pick an image. If the position is less than image URIs.size, that means that we should showing the image selected in the image view. So I'll delegate the work there to be in this bind method. So I'll say image URIs.position. On the other hand, if position is greater than or equal to the size of the image URIs, the user hasn't yet picked an image at this point. So we'll just say holder.bind. There's not really much to do, but we're just going to define this method .bind. So there are two methods now that we're going to define in the view holder. One which is bind without any parameters, and the other has one parameter, which is the URI at that position. The view holder is wrapping the custom view that we defined in cardImage.xml. So we'll grab a reference to the image view by saying private val ivCustomImage, and that'll equal the find view by ID on the item view. Now that we have a reference to the image view, in the first version of the bind method, the one which takes in a URI, all we need to do is set the image URI on that ivCustomImage. And the other thing we'll want to do is set a null click listener, which basically means that we don't want to respond to clicks on this image view. So in the second case, this is where we want to actually be able to listen for the user tapping on this square, on this image view, because that will be an indication that they want to choose an image. So what we'll do is we'll say ivCustomImage.set on click listener, and we'll implement this in the next part. The goal is to launch an intent for the user to select photos. Let's try it and see what it looks like. So as our app gets a little bit more complicated, one thing that's worth investing in is thinking about how can we improve the efficiency of getting to the CreateActivity. Right now we have to go into the menu, tap on a couple different buttons, and then finally get there. One thing we can do, which is a hack for developer efficiency, is back in MainActivity, in the onCreate function, we can directly create the intent to navigate to the create activity. So this will be similar to what we're doing when we tap on the menu option, but we'll just do it right away. So I'm going to create a new intent, pass in the medium board size, and then launch the activity right away. This is definitely not something that we want to ship to production, but in general, anytime you have an opportunity to improve the efficiency with which you develop, it's worth investing in. So now when we start the app, you can see we get a brief glimmer of the main activity, but now we're navigating directly into the create activity. We're seeing 9 gray squares here because we hard-coded in the board size of medium, and what these gray squares are communicating to the user is that they can tap on them in order to select a photo from their device, and that will be what's used in order to create their custom memory game. One quick improvement we can make is if I scroll up or down in the recycler view, we see this purple shadow, which communicates to the user that there's no more content in the recycler view, but that doesn't make sense in our context because we are guaranteeing the size of the recycler view. So if we go into the RV image picker and look for over scroll mode, then we can set that to never and address that issue. Okay, one quick tip I wanted to share with you. If you're using an emulator like I am, then in the next part, we're going to be using some photos that live on your phone or on your emulator as part of building out the app. And so if you're like me, you probably don't have some photos by default on the emulator. And so I wanted to show you really quick how you can do that. So if you have a image like this one, then all you need to do in order to have it show up in your emulator is drag and drop it onto the emulator. And that'll copy the file. And now in order to have it show up, open up the list of all apps and look for photos or whatever is your gallery app on your emulator. Open up that gallery app, and I found that sometimes it's helpful to force restart the Photos app and then open it up again, and hopefully we should now see this new photo that we drag and dropped onto the emulator. Now we can see the image that was previously on our laptop, and now it's on our emulator. So this is the easiest way for you to take images that are on your computer, drag them into the emulator, and then you can use them in subsequent parts when we start to build out the ability to choose photos from your phone in order to customize the memory game. In the next segment, we'll hook up the behavior of what should happen when a user taps on these gray image views. In this segment, our goal is to hook up the click listener when the user taps on any one of these gray squares or image views in the recycler view. And the way we'll do this is once again quite similar to what we did with the main activity, which is that in the image picker adapter, we're going to define an interface, and that interface will have one method indicating that the user has tapped on this element, and that will be how the create activity gets informed of a click, and the create activity is what will launch the flow for allowing the user to pick a photo from their device. So let's define an interface here. Image click listener. And then this is going to have exactly one function inside of it, inside of this interface, called onPlaceholder clicked. And the final parameter of the adapter is going to be an instance of this image click listener class. So private val image click listener, and it's of type image click listener. In the view holder, when we bind the set on click listener on the image view, we're going to invoke the onClickListener method of the interface. So we'll say onPlaceholder clicked for image click listener. And so now back in CreateActivity, we need to pass in this fourth parameter, which is the instance of the interface. So I'll write object here, and this is defining an anonymous class which implements that interface. Image click listener. And there's one method we need to override, and Annotator will help us with that. And tap on implement members. And here is where now on placeholder click means that the user has tapped on one of these gray squares, these image views. And so here is where we're going to launch the photo choosing flow. And I'm going to delegate that into a method called launch intent for photos. So this is the second time we're dealing with intents now. We had one intent to go from the main activity to the create activity. We're also going to have an intent here to launch the flow for the user to pick a photo. And this is called the implicit intent because we don't actually care which application on the phone will handle this intent, this request, but we just want the user to choose either Google Photos or a gallery app or something else on their phone, which will allow them to pick an image for our application to consume. So what we had earlier was an explicit intent because we were explicitly navigating to this CreateActivity. And here, the CreateActivity is going to launch an implicit intent to allow the user to choose an image. So let's define this method. And I'll put this at the bottom below all of the overridden methods. And here, we're going to have an intent. And because this is an implicit intent, we're going to just pass in intent action here, intent.actionPick. And there's a property on the intent called type, and we're going to pass in image/star. Communicates that we only really care about images. We don't want video files or PDFs or any other kind of file. And we'll pass one extra into the intent. So we'll say intent.putExtra, and this is a constant on the intent class, intent.extraAllowMultiple. So extraAllowMultiple is a constant defined on the intent class. So this is the key, and the value is true. Basically what this means is if the app that the user opens up supports it, we want to allow the user to select multiple images. And this is valuable because if I have to pick 12 images one at a time, that can get tedious. Instead, I might say, I want to pick all the photos from today, have all of them be imported into my application. So once we have this, now we can say start activity for result. And we're going to say intent.createChooser. And we're going to pass in the intent that we just created called intent. And then the second parameter is a car sequence or a string. We'll pass in choosePicks here. And this is basically some text which shows up when the user has multiple apps on their phone that can service this request. And the second parameter to start activity for result, similar to last time, is a request code. So I'm going to define a request code, pick photos request code, and we're going to define this inside of the companion object of CreateActivity. So inside the companion object, we will define this const val pick photo code, and I'll set it equal to 655, which is the street address of my favorite dorm at Stanford, Brenner Hall. One really important observation about what we're doing here is that with this request, our application is going to need access to files on the user's phone. And by default, the Android system doesn't give your app this permission. This is where we're going to have to request permissions in the Android permission model. The first thing we'll do is open up the Android manifest file, and at the top, let's declare that our application uses this permission. And the permission is called read external storage, because, for example, if the photo is located in the downloads or document directory of the phone, we're going to read that location of storage, which is external to our app. There are two kinds of permissions in Android, normal and dangerous. Read external storage is a dangerous permission. And what that means is just writing uses permission, read external storage in the Android manifest isn't enough for our app to actually exercise that permission. Instead, at runtime, the user has to be shown a dialog which informs them that this app, my memory, is trying to use this permission. Do you want to allow it or reject it? And so that's what we're going to implement next. So before we call this launch intent for photos function, we need to check if the user has granted the permission or not. So I'll say if is permission granted, then we can go ahead and call launch intent for photos like normal. But if not, then we need to actually request permission. What I've written here is pseudocode, so it won't actually compile, but I just want to walk through the logic. If the permission is not granted, then we need to first request permission and then get a callback if the user has accepted, and then once again call launch intent for photos. To properly implement these, we need to make calls into Android system functions, and I always have a hard time remembering them, and I find them a little bit verbose and hard to parse. And so I'm going to create a utility class called permissionUtils and have all the messiness of interacting with the Android permissions API in that class. Inside of permissionUtils, we'll define two functions. First is permission granted, and this will take in a context and a permission string, and it'll return a Boolean on whether the permission is granted or not. And the body of the function will be context compat check self-permission with the context permission, and we see if the return value of that is equal to packageManager.permissionGranted. The second function is request permission, which takes in three parameters. First is the activity, which you'll need to import, the permission, which is a string, and a request code, which is an integer. And the body of the function is activitycompat.requestPermissions. With the activity, we need to pass an array of permissions, so we'll construct that in line right here, and then the request code. So back in CreateActivity, let's actually use these permission utils functions. In isPermissionGranted, the first parameter will be a context, so we'll pass in this at CreateActivity, and the second parameter is a string representing the permission. So for that, I'm going to define it as a constant called readPhotosPermission in the companion object, and this will be coming from android.manifest.permission read external storage. So pass that in. For the second function, requestPermission, I first want to define the request code. So I'll say read external photos code and make it equal to 248. Doesn't really matter what it is, but as a best practice, we should keep the two request codes distinct. In request permission, the first parameter is the activity, so I'll pass in this at CreateActivity. Second is the permission, which is read photos permission, and the request code is what we just defined. We're almost done now. This request permission function is going to launch an Android system dialog asking the user if they want to allow my memory, this app, the read external storage permission. Regardless of whether the user accepts or rejects, we will get a callback called onRequestPermissionsResult, and that's what we'll override. There are three parameters here. The first is the request code, and the third one, which is what we'll care about, is the grant results. So the first thing we'll do is check if the request code is equal to the read external photos code that we used to launch the permission dialog. Then we'll check the grant results, and it should be non-empty because we're getting the results here, and we'll check if that is equal to permission granted, which means that the user has granted the permission. If this happens, we can go ahead and call launch intent for photos. If not, the user has rejected our app from getting the permission, and we should inform the user the impact of this. So we'll show a toast, and we'll tell the user, in order to create a custom game, our app needs to have permission to get the photos from their phone. Let's try it. And once we run the app and we tap on one of these image views, these gray squares, if we've done our job correctly, we should now see an Android system dialog asking if we allow this application the read external photos permission. So I tap on it, and you can see we do have this pop-up show up, and this is a dialog that we didn't write. It's coming from Android. So let's actually start by hitting deny, and then we get the toast that we wrote. Now let's show one more time, and let's allow it. And now, as a result of that implicit intent, an application on the phone is opened up, Google Photos, which allows us to pick one or more photos that we can then surface in the My Memory app. Let's go ahead and pick these set of 3 images and tap on done. And you'll see that we don't actually update the UI at all with the images that we get back from the intent, from the on activity result. And so let's fix that and show the images here. Back in CreateActivity, the place that we're launching the implicit intent is right here. And when we call start activity for result, whatever is the result of the launched activity will come back in a function that we're going to override called onActivityResult. The first thing I want to do in onActivityResult is check the request code. Does that match up with the request code that we passed in? Pick photo code that we passed in to launch the activity. Do those match? If so, then we know that we're processing the onActivity result for the right intent. And actually, I'd like to do the negation of this because there are several cases where we know the data we get back is invalid. If the request codes don't equal, if the result code is not activity.resultOK, or if the data is null. In all 3 of these cases, we should log a warning and return early because we won't be able to find valid photo data. So we're going to add a log statement here, and we'll log at the warning level, log.w, did not get data back from the launched activity. User likely canceled the selection flow. Now let's go up and define the tag in the companion object. Private const val tag is equal to CreateActivity. And if any of these conditions are met, we will simply return early. On the other hand, if we've gotten this far in the function, we know we have valid data inside of the data intent. And I've tested this on several different devices, and based on my experience, there are actually 2 different attributes that we care about on the data intent. First, if the application that's launched in order for the user to pick a photo only supports picking one photo, then the selected photo will come back in the data.data attribute, and that'll be a URI. On the other hand, if the application launched supports picking multiple photos and the user picks multiple photos, then that data will come back as part of data.clipData. And we will prefer to use the clip data because that will have multiple images. And so the first thing we'll do is check if clip data is not equal to null. And in that case, we'll log at info level the clip data num images, how many items are in the clip data, along with the actual contents of the clip data object. Now we're going to iterate through the clip data. So I'll say for I in 0 until the clip data item count. We'll retrieve the clip item at that position in the clip data. And now what we'll do is we want to get the image URI out of the clip item object. So we're going to add this image URI into the chosen image URIs. And you'll remember we passed in the chosen image URIs into the adapter. And so having the image show up in our RecyclerView is as simple as adding it into chosen image URIs. So first we'll check if we still need to populate the chosen image URIs, check the size. And if so, then we can go ahead and add the clip item.uri into the chosen image URIs. The other case is if selected URI is not null. So in that case, we'll log the selected URI with a tag and just print it out. And we'll also add it to the chosen image URIs list. The reason we're able to add selected URI unconditionally in this case, whereas before we had to check the size of the chosen image URIs list, is because if we get into this method on activity result, that means the user has tapped on the gray placeholder image view. And that means there's space for at least one more image in the chosen image URIs list. On the other hand, in the case of clip data, the user might have picked an arbitrary number of images, for example, 20 images, but we only want the amount specified by num images required. That's why in every iteration of the for loop, we check how many images are in our URI list. Now we have added the image URIs into the list so we can notify the adapter that the underlying dataset has changed. In order to do that, we need to make the adapter a property or a member variable of the class. So let's do that. Well, adapter is equal to that, and let's just set the image picker adapter to be adapter. And now this adapter, it shouldn't be locally defined, it should be defined as a member variable. So let's do that. Private late init var adapter, image picker adapter. And so now let's get rid of the declaration here and just set this equal to the property. Awesome. So now coming back here, you can say adapter.notify dataset changed. One more thing we should update is the title of the activity, which informs the user how many images they've picked so far. So on the support action bar, we'll update the title attribute to say choose picks, and now the numerator will be the size of chosen image URIs, and the denominator will, similar to last time, be the number of images required. All right, let's try it out. Okay, so we're in the creation activity. Let's go ahead and grab all 3 of these images. Awesome. So we can see right away that the first 3 image views in our grid of 9 are populated with those images that we picked. And if we look at logcat, we can see the log message from the CreateActivity at info level, which says the clip data num images is 3, which makes sense because that's how many images we're seeing in our RecyclerView. Let's also try out the case where we only pick one image. So we'll tap on the gray image view, which is a placeholder, and select the image of Rochester downtown, tap on done, and now we can see that gets populated. And again, the logcat shows that this is clip data, which means that we're falling into the case of the clip data not being null. So on this phone, we are always getting clip data back. I have found that on some phones or in some applications where you're not allowed to select multiple images, that's when you get into the case of the selected URI not being null. Try it out on your phone and see what happens. One more thing worth pointing out is that once an image is shown in an image view, you can no longer click on it. So if we go into image picker adapter, we're setting the click listener to null, and that's what is preventing the click from being registered. And that's a product decision that once an image is picked, then the user has no ability to change it. And if you wanted to, you could modify this behavior to allow this kind of edit functionality. But for now, we're going to leave it as is. Notice at the top of the activity, we have the action bar title to say choose picks, 4 of 9. And it looks like I am missing the ending parentheses. So let's go into CreateActivity and fix that. There's one final thing I want to get started on in this part, which is the logic to enable or disable the save button. There are 2 conditions that must be met in order to enable the save button. First, all the images must be selected. So in this case, we have 9 images. All of them have to be valid images. And second, there has to be a valid game name in the edit text. And so when either of those two components on the screen changes, that's when we might be enabling the save button. So in the bottom of the onActivity result, which means that the image has been selected, I'm going to call this method should enable save button. This function is responsible for deciding whether we should enable the save button or not. But for now, let's simply return true and try this out. So now, as soon as I select any image and I come back into the CreateActivity, now you can see how the save button is enabled because we're returning true there. Nothing happens when I tap on that button. The handling of that will happen in subsequent parts. This was a really critical part of the creation flow, dealing with permissions and intents and filling out these images in the grid view. All right, this segment should be a little bit lighter. Our goal is to properly figure out whether we should enable the save button based on if the user has met the 2 conditions in order to save a new game. First is they have to have picked out every image, and second, they have to fill out a custom game name. The first condition is if the size of the chosen image URIs list is not equal to the number of images required. And that means the user hasn't picked enough images for the memory game size desired. And in this case, we'll simply return false. The button should not be enabled. The other condition is around the length of the game name that the user creates for this memory board. Obviously, an empty name is invalid, but we also want to mandate a minimum length of the name. For example, a single letter like A or B shouldn't be a valid name. So we're going to have 2 conditions. If the etGameName.text, if it's blank, or if the length is less than 3, then we want to return false. And otherwise, we can return true, which would enable the button. We're currently calling this method should enable save button whenever the user has picked an image, but we also would like to call it whenever the text of that edit text at the bottom for the game name has changed. So in the onCreate method, we're going to add a text change listener on etGameName. We have to provide as the parameter a text watcher. So say object text watcher, and this has 3 methods that we need to override. And we only really care about the first one, after text change. So I'm just going to delete the body for the other 2 and leave them as empty. And the logic here is very simple. We're simply going to call that method should enable save button again, and that will dictate the is enabled property of the btn save. So every time the user makes any modification in that edit text, we will potentially enable the save button. One more thing that we should do here is set a maximum length of the game name. So if the text of the game is too long, it'll be painful to share it with friends and family. And so we're going to restrict the maximum length to be 14 characters. And this turns out to be pretty straightforward. There's a filters attribute on the edit text, and we are going to set that equal to an array of filters. And we're going to pass in one filter, and it'll be an inbuilt filter called input filter.length filter, and we pass in 14, which is the maximum allowable length. The result of what we've done is that the minimum length of a game name is 3 characters and the maximum is 14. This is a general good engineering practice, which is always validating user input. No matter what the user does, the application should never crash. And the steps we've taken here help to prevent anything unexpected from happening. Along those lines, one more good practice is to define constants for these key values. For example, the minimum game length and the maximum game length can both be constants. So min game name length will be 3 and max will be 14. So now it's very obvious in the code what these magic numbers represent. So I'll pass in the max game length and the min game length as appropriate. Awesome. So at this point, if the save button is enabled based on the logic we wrote, the user should be able to take the data that they've collected and save all of that to Firebase so anyone in the world can play their custom memory game. So in order to make that happen, let's add a click listener on the save button. And the code that will execute when the button is clicked is going to be a method that we're going to define in a little bit called save data to Firebase. This method is responsible for taking all the images and the associated game name and saving that to Firebase. So let's have Android Studio create this function, and I'm going to move this private function down below any of the other override functions that we have. The actual logic of integrating with Firebase, we will do that in a subsequent segment. But for now, I want to put a log statement here, and I want to write some logic for downscaling the image. And the reason why I want to downscale is because the images typically on your phone are going to be quite large, more than a megabyte or 2 megabytes. And we're only showing the image in the memory game in a very small square. So downscaling the image means that we are able to use up less storage in Firebase storage. And also when we download the image, it'll be faster to download. If you only have a few hundred users, then the amount of storage you're going to take up on Firebase storage is going to be minimal anyway. So feel free to skip this part if you're not interested. But it's also something interesting to learn about. So let's put a log statement here. And I'm going to have a for loop, which now iterates over the chosen image URIs. And we're going to iterate through it with both the index and the element. And I'll call that photo URI. So we'll have this chosen image URIs that with index. So I'm going to define a method called getImageByteArray. And this will take in a photo URI. And this will return to us a image byte array. And that image byte array is what we're actually going to be uploading to Firebase storage. And this method is going to take care of all of the downgrading of quality that we want. So let's define this method. And the return type should be a byte array. The first thing we'll do here is get the original bitmap based on the photo URI. And this will depend on the API version of the phone that this app is running on. So I'll call this original bitmap. And if the build.version.sdkint is greater than or equal to P, which is Android Pie, then the way to get the original bitmap is by using something called imagedecoder.createSource, content resolve photo URI, and then we call imagedecoder.decodeBitmap with that source. Otherwise, if we're running a lower version, then we'll say mediastore.images.media.getBitmap content resolver with the photo URI. So if this conditional is interesting, what it means is that if the phone operating system that we're running on is running Android Pie or higher, then the original bitmap will come from running those 2 lines of code. And otherwise, on an older version, we'll run this 1 line of code in order to get the original bitmap. Now let's log the width and height of the original bitmap so we can compare the size now versus after we scale it down. So we'll log at the info level original bitmap.width and original bitmap.height. So I'm going to invent a method here called bitmapScaler.scale to fit height, passing the original bitmap along with 250. Let's define this class now, and I'm going to extract it to a separate file and put it into the utils directory. Tap on OK. And the idea of bitmapScaler, similar to permissionsutil.kotlin, which we defined earlier, is simply to create a nicer looking API or a nicer looking method around some of the Android APIs. So rather than typing out the code, I'm just going to paste it in and then we can talk about it. So as the comments describe, the intention of these methods is to keep the same aspect ratio of the bitmap, but scale it down as per the width or height passed in. You can read through the math that's happening here in order to scale the bitmap appropriately. It's not that complicated. But the broader point here is that whenever you're able to take something complicated or harder to understand and wrap that around something simpler, that's a big win. Computer science is largely about communication. And what we've done here is we've taken something which is harder to communicate and wrapped that complexity into something which makes it much simpler. And that's a huge win. Now let's turn this into an object because this is a utility class. It doesn't make sense to have multiple instances of bitmap scaler. So we can just call bitmapScaler.scale to fit height with a height of 250. And once we've done that, now let's print out the scaled bitmap width and height. The last thing we need to do in this function is to return the byte array. And so at the bottom of the function, we're going to define a new byte array output stream. We'll take our scaled bitmap and then call the compress method on it, and we'll pass in a compress format of JPEG. The second parameter is the quality reduction. 100 means no reduction in quality, and 0 means a severe downgrade in quality. So we'll pass in 60 here, and then we'll pass in the byte array output stream that we just defined. And finally, we'll return byte output stream dot to byte array. So at this point, we have gone through and downscaled the quality of each image the user has selected. The job for the next part will be to figure out how to upload this to Firebase storage. At this point, we have the list of all the images that we want to upload to Firebase, and we've downscaled them appropriately. And we are now converting them into a byte array, which is what Firebase will take in the upload process. So in this segment, we're going to write the core logic for taking these photos and actually uploading them to Firebase storage. This will obviously require the use of the internet in order to communicate with our client, our Android device, to Firebase storage. So let's open up Android Manifest and add in the internet permission. One thing to observe here is that internet is a normal permission, while read external storage is a dangerous permission, which means that we don't need any of the runtime permission logic that we needed for read external storage. We get internet permission for free. In order to now upload this into Firebase, we need to have a new Firebase project. So what you should do is go to console.firebase.google.com. Let's tap on Add Project. And let's call this project My Memory. Continue. And then let's disable Google Analytics for now. It's not strictly required for what we're building. And now Firebase will take a couple seconds in order to build out your Firebase project. All right, so we're done. Let's tap on Continue. And we're going to add an app, an Android app, to get started. So we're going to associate our Android app to this Firebase project. So for the package name, let's go back into Android Studio, go up to the very top, and then here is our package name, which is the thing that we had defined at the beginning when we were creating a new project. Copy that. I'm going to leave the rest of this blank and say register app. And now we need to download this file, googleservices.json. And what we want to do is we want to actually drag this into the app directory. So the way we can do this is, as shown in that photo, go into the project tool window, go into the project perspective of your project, and inside of the app directory is where we're going to drag and drop that Google services.json file. So I just dragged it in, and now Android Studio is saying move file over. So I'll say yes, I do want to move this file over. And now we can see we have Google services.json. So now let's go back into the browser and see what else we have to do. So now we have to add in the Firebase SDK or software development kit into our Android app. So in the project level build.gradle file, we want to first check if we have the Google repository, and also in the dependency section, add class path. So let's go back into the Android perspective. In Gradle scripts, the one which is in the root level, we already have Google up here, and we also already have Google down here. We just need to add the class path for Google services. Tap on sync now. Now, in the app level build.gradle file, we want to add this line for the GMS Google Services plugin. So let's exit this build.gradle file and open up this one. And here at the top is where we're going to add that. Copy that line, and we have to modify this to match the format. Like that. And now we need to add the dependencies for whatever parts of Firebase that we want. So Firebase actually has dozens of services within it. We're going to only really need a couple of them. So I'm going to copy this line for the Firebase bill of materials. So we added that. And now below this, we're going to add the dependencies for whatever products that we care about. So let's open up this URL. There are two products in Firebase that we care about: Firestore and storage. So first off is Cloud Firestore. And make sure that you're actually in the Kotlin tab here. So you get the Kotlin version of these libraries. So we're going to have to say implementation with this library. And then the second product is cloud storage. And the nice thing with including this build of material is that we no longer need to specify the version on each Firebase product that we're adding in. So let's tap on sync now. Now we've pulled in Firebase into our project. Let's go back into our browser, tap on next here, and then tap on continue to console. And here we need to enable the two Firebase services that we're going to integrate into our project. So let's start with storage and then tap on get started and tap on next. choose a location which is close to you. So for me, it's US Central. Tap on Done. So now we have Firebase storage set up. Go into the Rules tab. And by default, read and write are only possible if there is a logged in user on the client who's doing the request. And we don't have a notion of an account or a logged in user in our app. So I'm just going to set this equal to true. And then if you're publishing this app, of course, you want to kind of be more mindful about who you're allowing to read and write data into Firebase storage. But for our purposes, this is going to be fine. The other product that we're going to use is Cloud Firestore. So I'm going to create database. And we're going to start this in test mode. And test mode basically is something similar to what we just did. It's saying that anyone can read and write to our Firestore database as long as the timestamp of the request is within a month. So for the next 30 days, anyone can view, edit, or delete data in our database. And again, we're going to pick the same location. Perfect. So now we have our two products set up, Firestore and storage. I wanted to spend just a couple minutes describing how Cloud Storage and Cloud Firestore work together in order to allow the user to create a custom memory game in our application. Because this is the most critical part and most complicated part of our application. So when the user creates a new memory game, they're going to pick various images from their phone. And each of them will be stored inside of Cloud Storage. And when we successfully upload something into Cloud Storage, we're going to get back a URL which defines how we can retrieve that image later on. So once we have a list of image URLs for each photo that the user wants to attach into their memory game, we're going to then take those list of image URLs and upload that or push that to Cloud Firestore along with the associated key. So for example, in this case, we have a memory game called Corgi, and Corgi will have 4 unique images associated with that, which is how we're getting 8 memory cards, and that will live in Cloud Firestore. And so now when another user somewhere in the world wants to play this game, this Corgi game, they can type that into the memory game app, and we will pull down all the images from Firestore associated with Corgi. And that'll be a list of 4 different image URLs. And that's how we'll be able to allow the user to play this custom game called Corgi. So the complexity here is due to the fact that uploading these images is an asynchronous operation. So there are 2 kinds of programming. One is asynchronous programming and the other is synchronous programming. So most of the operations that you might be familiar with are probably synchronous. For example, if you're doing 2 plus 2 or any kind of simple arithmetic in Kotlin, or if you're combining strings, those are synchronous operations in the sense that when you execute that, you can expect a result immediately. However, what we're dealing with here is asynchronous, which means that when we execute the operation, we will not immediately find out whether it succeeded or failed because it might take a longer amount of time. Image uploads are a good example because images are inherently quite data rich. There's going to be a lot of data, and uploading that over the internet, anything you do with the internet is going to require more time. And so we're going to start the upload process on all the images that the user has picked out for their custom memory game. In this case, where the user has picked out the Corgi game, and we're going to start uploading all of them into Cloud Storage. And the tricky thing is that the rate at which these images get uploaded is not in our control. So for that first image, it might be halfway done uploading. The second image might be totally done uploading, and so on for the third and fourth. We might have a different rate of uploading. And so the question now becomes, how can we figure out when all of these operations have succeeded so we can record the image URL corresponding to each image that we've uploaded? And the way we'll do this is by getting notified when each image has successfully been uploaded. So as soon as the image reaches Cloud Storage, we'll get a corresponding download URL for that image. And we'll track how many download URLs have we received. And if the size of that list of download image URLs is equal to the number of images that we're uploading, then we know we're done. And so we're going to continue this upload process until we get to this state, which means that all the images have finished uploading. And now we will have a list of image URLs for each of the 4 Corgi images that we have. We're going to combine that with the custom game name, which is called Corgi, and that is what we're going to send to Firestore. That is what we're going to implement, at least partially, in this segment. So let's go back into Android Studio. The first thing we'll do is get a reference to Firebase storage and Firestore. So at the very top of the file, Kotlin, the library that we included, makes this super easy. We'll just say private val storage is equal to firebase.storage, and then private val db, which represents Firestore. And so going back now to where we have defined this image byte array, our goal is to upload these into Firebase storage. The way that works is we're going to define a file path on where this image should live in Firebase storage. And I want this file path to actually be dependent on the game name. So if you ever wanted to look at this from the Firebase console, it'll be easy to tell which images belong together. So custom game name, let's define this as etGameName.text. And then inside of that directory, let's specify the current time in milliseconds dash the index. And then this will be a JPEG file based on the logic that we wrote in getImageByteArray. And so the idea here is that if I have 4 images, for example, in the Corgi game, then that'll be saved in images/Corgi/ the current time in milliseconds dash 0, 1, 2, 3, because there are 4 images. This is a nice way to combine all the images associated with one memory game. So now we have exactly what we need to upload the image to storage. We have a file path and the actual underlying data for this image. So we'll get a reference to the location of where we want to save this photo, which will be storage.reference.child with that file path that we defined. And we'll put the image byte array data at that location. All right, so this is the operation which will actually do this expensive work of uploading the bytes representing the image to Firebase storage. And so instead of getting the result of this as some return value here, we will instead get a task which we have to now wait for until it succeeds or fails. And so the way we can do this is we're going to say continue with task. And what that means is this is an API defined by Firebase which says this is a long-running operation. Once it concludes, then I want you to execute this code, and I want you to also execute one more task. So we're going to define what that is at the end. But first, the result of this put bytes is a photo upload task. And from here, we can actually conclude how many bytes were uploaded, just to get some more info about what happened. So photo upload task dot result, and then if it's not null, then we can check this bytes transferred field. Okay, and then we have to end this block, this lambda block, with another task. That's why we wrote continue with task. And the task we want to continue with is once this photo has been uploaded, now we want to get the corresponding download URL. Photo reference dot download URL. Now you can see how the error went away. Again, getting this download URL is going to give us a task. And so now we have to wait for the completion of that task. And that's an asynchronous operation. So in order to get notified of that, we'll call add on complete listener. And the parameter here will be the result of this operation that we just triggered. So it'll be called download URL task. And the first thing we want to check is, did this operation succeed or not? So if download URL task if it didn't succeed, then let's log an error. And let's also show a toast telling the user failed to upload image. If any of the images encountered an error while uploading, let's set this as a Boolean flag here. Did encounter error is equal to true. So initially this variable is going to be false. So var did encounter error is equal to false. And then if we encountered an error in uploading any of these images, then we're going to set that equal to true. And if this happens, we're going to do a premature return because there's no point continuing. The important thing to realize is that this add on complete listener will be called for every image which is uploaded. And we don't control the order in which these are called, right? And so if this particular image URL failed to upload, then we'll go into this if block. But if some other image upload failed, then we wouldn't actually know from here. And that's why we actually added this Boolean did encounter error. So if did encounter error is true at this point, that means that some other image has failed to upload. And we again want to just return from the add on complete listener because there's no point in continuing. Otherwise, we have been able to successfully get a download URL. So I'll look inside the task, look at the result, and then cast it to a string, and that will give me a URL. And at this point, now we want to make note of the fact that this image has successfully been uploaded. The way we'll do that is by keeping an array of all the images that have been uploaded so far. So we'll call this val uploaded image URL, and that's equal to a mutable list of a string. So down here, we'll say uploaded image URLs dot add, and we'll pass in this download URL. Now let's put a log statement here saying log.i with this tag, and we'll say finished upload photo URI. So if we think back now to that diagram, how do we know when all the images have been uploaded? Turns out that's pretty easy, right? Because we're keeping a track of all of the images that have succeeded so far in this list, all we need to do is check the size of that list. So if the size of uploaded image URLs is equal to the number of images that the user has picked, then we know we're done. So we'll say handle all images uploaded. So this is, in some sense, the success callback for the images having been uploaded. And from here, in this method, we're going to pass in the game name and the uploaded image URLs. And this is exactly the information that we need, if you remember, to upload into Firestore. So that's what we're going to handle later on, uploading these two key pieces of information into Firestore. Let's rename the parameters here to be image URLs and game name. All right, that was some pretty heavy logic to think about and implement. Let's test it out and see if it works. The one thing I want to do is, right now we're launching the CreateActivity with the medium-sized board, which requires me to upload 9 images. That's too much for me. I'm feeling lazy, so I'm going to change this to be the easy board size. Rerun the app. So we only have to upload 4 images now instead of 9. Let's tap on one of these images and let's grab these 3. So now we have one more to upload. So let's get this panda picture. Okay, so we still can't save the game because we haven't given it a name yet. So let's say testing. Okay, so now, because we've added a valid game name, now this save button is enabled, and this tapping on the save button is what will trigger these images to be uploaded into Firebase storage. So let's try it. And before I hit save, I'm going to open up Logcat. And as we upload images, we should see this log message in the CreateActivity for the number of bytes that are uploaded, along with the progress, the status of how many images have been uploaded so far. Let's see if we can see those. Okay, awesome. So we can see that we have sporadically these log messages. Let's filter for CreateActivity, because that's all we really care about. So you can see how the original width was a certain dimension, and the scaled width is smaller because we're restricting the height to be 250 dp. This is logic that we wrote from before. Now we have 4 images that we're uploading. So you can see we have 4, we're seeing this uploaded bytes log message 4 times, which is great. And as we upload each image, we can see that the num uploaded goes up each time. Awesome. So now to validate that this properly worked, let's go back into the Firebase console and check Firebase storage. We don't expect anything to change in Firestore, but in storage, we should hopefully have one extra directory in storage for this game. And that's what we see exactly here. So we have a directory called testing, and this should have 4 images. They're all prefixed by the current time in milliseconds, followed by the index, which is what we have here. And if you look at the preview, we're seeing exactly what we had uploaded, which is really promising. Awesome, that looks really good. And you can see kind of the rough size. This is around 14K, 4K, and about 2.7K. So this is really pretty small, so we're not actually eating up too much of the storage capacity in Firebase storage. And it's also going to make our app feel a lot faster because we're downloading less data as well. And here's what the image looks like in the browser. In the next segment, we'll finish off the missing link of taking the image URLs that we have along with the custom game name and uploading that to Firestore. So we're now able to upload images into storage, but we haven't made the link yet to storing those image URLs into Firestore. So that's what I want to do with you right now. So if we open up Android Studio, here's where we left the to-do for given this game name and the set of image URLs, we now want to talk to Firestore. The way we do this is reference the DB object that we have defined above, and we're going to put this data into a document. Firestore organizes its data into collections and documents. So all documents have to live in a collection, and one document represents one entity in our database. So each memory game will be one document, and that document is going to live in a collection, which we're going to call games. Inside of games will be a list of all the custom games that people around the world have created. And the parameter here is the path of the document, which is basically the name of this document, and it'll be game name. And here we're going to set the data associated with this game. And it'll be very simple. All we really want to do is associate the image URLs to a key called images. So images maps to image URLs. That is the data that we're going to put inside the document. Now let's get notified when this operation succeeds. Add on complete listener, and the parameter of this Lambda function will be a game creation task, which indicates if this succeeded or failed. So if it didn't succeed, game creation task is successful. Then let's log an error here. And if this happens, we'll return early. All right, otherwise, we have succeeded. So we can say successfully created game name. And then in this scenario, let's show an alert dialog to the user to communicate to them that they've made the game, and let's navigate back now to the main activity and play the game that they just created. The user is only going to have one option on this alert dialog, which is to tap on the OK button. And when they tap on the OK button, we want to pass back to the main activity the game name which has been created. So I'm going to create an empty intent here, and inside of this intent we are going to pass the game name. So I'll say put extra game name, pass in the game name, and then we'll say set result activity result OK, and result data. And then finally, once we've set that data properly, we'll call finish. And we're going to show this alert dialog. So we should define extra game name, and this will be defined inside of the constants file. Let's import it. Awesome, so let's try this now. If we wrote our code correctly, that means now we should not only upload images to Firebase storage, but also to Firestore. Let's grab a couple images here. Okay, so I added 4, and let's say test 2, and tap on save. Okay, so after a couple seconds, we can see that we got this dialog pop up which says upload complete. Let's play your game test 2. So that seems promising. Let's see if it actually worked inside of Firestore. So I go back to Firestore. Let's refresh this page, and hopefully we should see a new collection called games now. Yes, and we do. The document name is test2, which is the same as the game name. And inside of the document is exactly one field called images. And images is an array of strings. And each string represents the URL for the image. So for example, I could copy this URL, open it up, and we see one of the images that were uploaded. Awesome, this looks great. So there's a couple of things I want to improve on here. First, you might notice that in Save Data to Firebase, we are grabbing the custom game name based on the edit text, and we are unconditionally creating a new game with this data. However, if another user in the world has already created a game called test2 or testing or whatever it might be, then we're going to override that data, right? So we're going to go into Firestore, and when we call .set, all the previous data that was inside of that document, if there was a previous document, that will be overridden. And so what we actually want to do here is check if there already exists a Firestore document with this game name. So right here, the intention of the code that we're going to write is to make a check on Firestore and ensure that we're not overriding someone else's data. So the consequence of this logic is that once I create a game of a certain name, for example, ABC, no one else in the world can create a game with that same name, ABC. And that seems like a reasonable decision to make. So here, what we want to do is call db.collection. We want to target the same collection, games, and check, do we have a document with this game name? Let's get it, and that'll be how we figure out whether there is a game or not. So the result of this asynchronous operation in this callback is we get a document, and now we should just check if the document is null. And if the document is not null and the data of the document is not null, a game with this name already exists in our database. And so we should not allow the user to create another game with this name. So I'll say alert dialog.builder set title to be name taken, set message, set positive button, okay, null, dot show. All right, otherwise, we want to then execute all of this logic that we had from before. So I'm going to actually put all that logic into a separate function called handle image uploading. So let's create a function here, and then let's move. The parameter can be called game name, and let's move all of this logic into that function. And we renamed this parameter to be just game name. Awesome. So we added an on success listener. We should also add a failure listener in case, for whatever reason, we were not able to retrieve this document. I don't really want to do anything too meaningful here, just log an error so we can debug this if this ever happens. Perfect. And one more thing that I want to do is, as soon as the user taps on the save button, then we would like to disable the button. And the reason I want to add this button dot is enabled is equal to false as soon as the user starts making the network request is because if the user spams the button, they would be attempting to create the same game multiple times, which doesn't make sense. So as soon as they hit the save button, we want to disable it so that no more saves are triggered. And if we get a failure, then we would like to enable the button again. So they can fix this issue and change the name of the game, and then they can try saving it one more time. And same thing down here, actually. If there was a failure for some unknown reason, like a network error, then we'll allow them to retry by setting the button to be enabled again. Let's try that logic. So we already have a game that we just uploaded called test2. So let me grab some images. Call this test2 and save it. And hopefully we should see an error saying name taken. Perfect. So we say name taken, a game already exists with this name2. Please choose another. Okay. And now we have the save button enabled again, and we can try changing it to be test3. And now hopefully this should work. So you can see while the image upload is happening, the button is disabled. So the upload is complete, and now we can go back to Firestore, and now we have test3 here with these 4 images that we uploaded. Great. The last thing I want to do in this segment is I'd like to give the user some visual indication of how much progress has been made in uploading these different images. Because this operation could take some time, especially if you have the hard version of the memory game. So you have 24 cards or 12 unique images. Uploading 12 images could take a while. And so it'll be nice to provide the user some feedback on how many images have been uploaded already. And this turns out to be fairly straightforward. We can open up Activity Create, and what I like to do is drag out a horizontal progress bar. Let's actually create some distance with the save button. So I'm going to change this to be 150 dp from the bottom, just so we can create a bit more space. And now let's drag this out. And I want the save button to be anchored to the top of the progress bar. So get rid of that constraint and have this be restricted to the top there. And then the progress bar should be match constraint for the width. And then we'll set the left constraint to be 0 from the left end of the screen and also 0 from the right end of the screen. Well, it shouldn't be 0 dp, it should have some margin. So let's have maybe a margin of 16 from the left and right end of the screen. And also 16 dp from the bottom. Awesome, that looks good. So now as soon as we hit the save button, we want this progress bar to show up, and that will be the visual indicator to the user of how many of the images have been saved. The one thing here is that the progress bar should only show up when this upload is in progress. So initially it should be not visible at all. And so for that, I'm going to go into the progress bar and change the visibility to gone. And the other way you can do this is if you tap on that progress bar element and just search for visibility, you can change it to gone right here. Cool, let's give this progress bar an ID of PB uploading. Copy the ID because we'll need it for the CreateActivity. So let's go over here and call it PB uploading, and this is a progress bar. All right, let's define that right here. Okay, so now we have the progress bar. As soon as the upload starts, then we want to set the progress bar to be visible. So where does that happen? In Save Data Firebase, what we're doing here is checking if the game name is unique. So we're not going to set the progress bar to be visible here, but as soon as we start uploading images, that's when we want to set it equal to visible. So I'll say pb uploading dot visibility is equal to view.visible. And here, if we encounter an error, then we want to set the visibility to be gone again, because we won't make any progress at this point. View.gone. And the interesting thing happens whenever we have successfully uploaded one image. So right here is a success case. We want to update the progress of the progress bar. So I'll say uploaded image URLs dot size divided by the total number of images that we need to upload. So for example, in the hard version of the memory game, we have 12 images to upload, and we might have uploaded maybe 6 of them so far. So that would be 50% progress. So this progress requires some integer, but the integer should be something between 0 and 100. And so right now, this will always be 0 because we're doing integer division, which will lead to truncation. So in order to get something between 0 and 100, we're just going to multiply by 100. now the only thing left to do is let's set the visibility of the progress bar to be gone when we're totally done with everything. So when we get to the success case of all images uploaded, and we've uploaded this to Firebase as well, right here we can set the view to gone again. And actually, I think it makes sense to do this even before we check if the game creation task is successful or not. Because once we've gotten into here, we're no longer doing any network operation, so we should set the progress bar to be gone. Okay, let's try it. So in order to make it a little bit more visible, let's go back and choose the medium version of the game, just to have more images to upload. And let's pick all 6 of these images. Now we have 3 more to pick. Let's pick the 3 over here. And then let's call this large test. Tap on save. Awesome, so we see a progress bar, and you can see how it's slowly making progress to upload each of those 9 images. So that's pretty cool. And then when we get the progress bar gets to the very end, then shortly after that, once Firestore has informed us that it has successfully received the data, then we show this dialog, upload complete. So tap on OK, and then we go back to the main activity. Just to confirm this one more time, now we do have in Firestore this large test, and it will have 9 images instead of 4, because that's how many images we were uploading. So now that we're done with the creation flow in the main activity, that hack that we had earlier to automatically navigate there, let's remove that. After the creation activity is launched from here, then we're calling start activity for result. And so what we're going to do in the next segment is figure out the result passed back from the create activity, and if it's successful and we have a new game created, we would like the user to play that custom game. Now the user is able to create a brand new customized memory game. Our goal in this segment is to be able to allow the user to play that game in the main activity, in the main screen. And so we launch the creation flow with the start activity for result. So we're going to capture the result of whatever the child activity has done, the creation activity, in the on activity result method. What we'll do first is just check if the request code is equal to the request code that we launched this with, which is create request code, and if the result code is equal to result code activity dot result OK. So if that's the case, then let's retrieve the custom game name out of the data intent parameter. So get string extra game name. And so you'll remember the reason I'm doing this is because in the create activity, as soon as the operation to create the game is done, then we set the extra game name to be the newly created game. So that's what we're retrieving right here in the main activity. If for whatever reason the custom game name is null, then something has gone wrong, and let's just log that as an error. And we'll return early. Otherwise, we know that custom game name is non-null, so we have a valid game. So I would like to create a method called download game with this custom game name. Let's create this function. And the idea of this function is to query Firestore, retrieve the corresponding set of image URLs, and use that to play the game of memory instead of our default icons. So at the top of the file, we need a reference to Firestore, similar to what we had in the create activity. So right here, I'll say private val db is equal to firebase.firestore. And let's also capture the value of the game being played. So it'll be private var game name is a nullable string, and it's initially going to be null because when you're playing a default game with just the icons that we've predefined, there is no game name. But it's only set when the user is playing either their own custom game or a custom game made by someone else. So back in the download game method, we're going to query Firestore inside of the games collection. That's where everything lives. And we're going to try and retrieve the document called game name. Let's get it, and then that operation might take some time. This is an asynchronous call, so we're going to add a onSuccess listener. And we also will need to add a failure listener. And then this is easy. We're just going to kind of log this so we can keep track of what happened. Okay, so in the success case, here is where we're doing something interesting. We are going to get back a document which has one field in that document, which is called images, and that will correspond to a list of image URLs, a list of string. And so that mapping of taking this document, which is what we're going to get back here, and turning that into a Kotlin data class is something that Firestore will help us with. So we'll say document.toObject, and we want to map this to a data class that we're going to define. And I'm going to call it user image list. Like that. So let's define this now. Create class, and I want to put it into the models directory that we already have. And this is going to be a data class. There's no body. The only thing that we really need to define here is the field name of what this entity or this data class will hold. And there's only one, which is called images. So it'll be val images, and it's going to be a list of string. And it's going to be nullable. And the reason it's nullable is because Firebase mandates that every time you do this kind of mapping between a document you get back from Firestore and into a data class, it needs to have a default value. And so it's going to have a default value of null. And one other thing that we should do is annotate this field with a property name. I'll say property name images. And this is how Firebase will know that, okay, here's the key called images, which is defined over here, and it maps to this attribute, which is a list of string. Cool. So back in main activity, now that we've done this document.toObject, we will get back a val user image list. If user image list is null, or if the images attribute of user image list is null, then something has gone wrong. And the shorthand for this is to do user image list dot images. So we're going to log this as an error. Invalid custom game data from Firestore. Let's also put a snack bar here to just message this out to the user. CL root and then this is the error case, so we're just going to return early here. Okay, so if we've gotten past this return statement, if we've gotten past this if block, that means that we have found a game successfully. So now we want to reset up the RecyclerView with this custom data. So first off, let's compute how many cards are in our memory game. So val num cards is equal to user image list .images.size times 2. So for example, if there are 4 images inside of our image list, that means that the total number of cards should be 8 because we're making pairs. So now, given that we have 8 cards, we can now figure out the board size. The board size has to be one of the enums that we've defined over here. It has to be either easy, medium, or hard. And what we know is we know the value. So we need to figure out how to take the value, 24, and map that to hard, 18 maps to medium, and 8 maps to easy. And the way we're going to do this is by adding a companion object inside of the enum called fun get by value. And just as the name implies, based on the value that we pass in here, which is an integer, we're going to return one of these 3 enums. So we'll say the body of this function is going to be a one-line function. We're going to look at all the values of this enum through this method called values, and we're going to find the first one among this such that the number of cards in that enum is equal to the value. So this is a nice, cute one-liner. And the reason this is valuable is now we can set the property board size from before based on the number of cards. So number of cards. And we can also set the game name to be the game name defined here. This actually leads to some naming conflict. So I'm going to rename this local variable to be custom game name. And now it won't be ambiguous that I'm trying to set the property game name to equal the local variable game name. Okay, and so now there's a complaint here. Board size value of requires a string, but the actual is a int. Oh, it should be get by value. Okay. The next thing we want to do is call this method setUpBoard. But setUpBoard has to actually now have information about what is a list of image URLs, right? And we are not actually saving that inside of any property. So let's add that as a property now. I'm going to add one more private member variable called custom game images. And this is going to be a list of string. And it'll be nullable because in the default case, this list will always be empty, right? It doesn't make sense to have a list of image URLs when we're just playing with the default icons. So we're going to set this equal right here when we query Firestore and get back a list of images. So this is going to be equal to user image list dot images. So now let's go into setUpBoard and actually start using the custom game images variable that we have along with the game name. The objective here is we want to prefer using the custom image list, if it's there, over the icons, because that means that the user is explicitly intending to play this custom game. So the change that we're going to make is we're going to pass in the custom game images as a constructor parameter on the memory game. So let's add this as a parameter, hit refactor, and we're going to call this custom images. And here, the memory cards that our memory game is going to contain will depend on whether custom images is set or not. So if it's not set, so if custom images is equal to null, that means we'll just do what we've already been doing, which is to look at the default icon list, grab some icons out of those, and create memory cards out of them. However, if custom images is not null, then the memory cards should instead be using the image URLs as the underlying picture of that memory card. So we're going to say val randomized images is equal to custom images, and we're going to get 2 copies of each image in that list, then randomize it. And now the list of memory cards is going to equal randomized images.map, and we're going to create a new memory card for each of these. So one thing you'll notice here is there's an issue, which is that this randomized images here is a list of string. That makes sense because each element is an image URL, which is a string. But memory card, if you remember, the first parameter is a identifier, which represents the image resource, the drawable resource. And we don't have that in the case of a custom game. So what we're going to do is add one more constructor parameter called image URL. And this is going to be of type string. And this will be optional because in the case of the default game, doesn't make sense to have anything here. Having the default value of null here, we can create memory cards identically to how they were created before. But now, if we wanted to, we can also specify an image URL. And that's exactly what we're going to do over here. And pass in IT for the second parameter. And now the first parameter, we need to pass in some identifier, which is an integer. And so in order to do that, we now need to figure out how can we take an image URL and turn it into a unique integer. And the easy way of doing this is by using a method called hashcode. This is something that's defined on every single object, including strings. And the idea is that for 2 different strings, the probability of them having the same hashcode is very, very small. It's almost impossible. And so by having it.hashcode, we're just basically taking the string, whatever it might be, and translating that into an integer. And that will be our new memory card. So almost done. In the memory board adapter now, this is where we are actually rendering that drawable from the default list of icons. That happens right here. We're saying image button.setImage resource. So if the card is face up, we are setting the image resource to be that drawable resource, otherwise the background. However, in this case, we don't want to do this, right? In the case of a custom game image, if there is a image URL on the memory card, we would, instead of setting an image resource, we want to actually download that image from that URL. So in order to download an image and show it into an image view, there are a couple libraries on Android which make this super easy. And the one that we're going to use is called Picasso. So if you use Google for Android Picasso GitHub, you'll come to this page. And what you should do is scroll down to the download section and copy this line, implementation. Now add this line into the build.gradle, which is located in the app module. Tap on sync now. And going back into memory board adapter, now we can use Picasso to render the image at that image URL inside of this image button. So the logic will be, if the memory card is face up, then we should check, is the image URL of this memory card not equal to null? If it's not null, that means that there is a valid custom image at this memory card that we should be rendering instead of a resource identifier. So we'll call Picasso. So we have to import that, .get, and we're going to load in the image URL into the image button. That's how simple it is to use Picasso. Otherwise, we're going to do what we had before, which is image button.setImage resource on the memory card identifier. And this is going to be one of the icons that we had created. If the memory card is face down, then we're going to go into this else branch, and then we're going to set the launcher background. So just that. All right, so we just wrote a lot of code. Hopefully it all makes sense. Let's try it out. I'm going to run the app, and we're going to create a new game and save it. And then when we save it, we're going to come back into the main activity, and hopefully we'll be able to play this new custom game that we created. So I'm going to create a custom game, make it easy so we don't have too many images to upload. And let's do this. So 4 images here, and say play game as the name. Tap on save. All right, so we can see the progress bar, upload complete. So now we should be going back into main activity, and main activity should, at that point, fetch all these image URLs from Firestore and display them in the memory game. Let's see if it works. So now it all looks identical to what was there before, because right now everything is face down. But when we flip over a card, you can see, hey, it actually downloads this image that we had, which is amazing. I got lucky with a match on the first one. Okay, so this is working. So we're able to download the images from this custom game, and we can play the game like normal. So the logic of figuring out which 2 images are the same works because the hash code of these images, if they're the same image, should be the same. So that logic is all identical to what we had from before. Awesome, so we won, and we have the same logic there from before. All right, so to finish off, there are 2 really quick things I want to do back in main activity. So first off, in the setup board method, one thing that would be nice is as soon as we call setup board, if there is a custom game which the user is playing, we should change the title of this to be the name of the game rather than the default my memory. So in this case, we should hopefully have seen play_game as a title instead of my memory. And we can do that pretty easily just by saying support action bar .title and set this equal to game name. And the game name might be null. So in the case that it is null, then we want to set it equal to the name of the app. So r.string.appName. That's one thing I wanted to do. Second thing I wanted to do is a bug fix. So right now, one thing you'll notice is that if we create a new default game of a different size, we're going to trigger this method, show new size dialog. And so if the user is playing a particular game and they create a medium-sized game, then we're going to call setup board. But the issue is that setup board might still be using the cached data, the saved data inside of game name and custom game images. And so basically the key thing here is we need to reset these values every time the user goes back to a default game. So in the show new size dialog, right before we set up the board, let's just null out the game name, and also the custom game images should also be null. Awesome. Huge progress in this video. What I want to do next is allow the user to enter in the game name that they want to play using a menu option. But right now, the only way to play a custom game is by creating it, and then we immediately will play it back in the main activity. So what I want to do here is add one more menu option for downloading an arbitrary custom game. So to do that, we're going to add a menu option. So open up menu main, and we're going to add in one more final menu item. And let's give this a title of download custom game, and the ID can be mi download, the menu item download. And similar to the other two above it, we're going to have show as action be never. So we always want this to be in the overflow menu. Let's copy the ID, go back into main activity, and register a listener for when that menu item gets tapped. So r.id.miDownload, and in this case we would like to call this method show download dialog, and then return true. Okay, let's define this method. So I'm going to put this below the functions that we're overriding, and then I misspelled download, so let me fix that. So this download dialog is going to be simple. All it is the ability for the user to enter in through an edit text the name of the game that they want to download. So I'm going to use a layout inflator to inflate that view which has the edit text. So I'll say layout inflator from this, inflate r.layout.dialog download board. Null is the second parameter, and this is going to be a view that we're going to call board download view. And the idea is going to be, we're going to call that same method that we have show alert dialog. The title will be fetch memory game, and the view is going to be the board download view that we are about to define. And the third parameter is what should happen when the user taps on OK. So it'll be view.onClickListener. And what we want to do here is grab the value text of the game name. So let's first define the dialog download board layout. The root element here can be a constraint layout, that's fine. The only view that we need in our constraint layout will be an edit text. And before modifying individual attributes of the edit text directly here, one thing to notice is that we're going to be using many of the same exact attributes as the edit text that we showed in the creation flow. And so I'm going to open up activity create, and we have the edit text here. I'm going to go ahead and copy all of that, go into the code tab of the dialog download board, and copy over that same edit text. We'll have to add in the app namespace declaration. Many of the attributes, for example, the allowable input digits, number of max lines, input type, important for autofill, all of that should be identical in this edit text and the edit text in the creation flow. But there are a few modifications we'll want to make. Let's change the margin bottom to be margin top and make it 16 dp. Let's update the hint to say enter game name so the user knows what to do with this edit text. And the constraint bottom doesn't make sense anymore because there is no btn save. So I'm just going to say constraint top to top of parent, which makes it flushed with the alert dialog top. Finally, let's update the ID to be ET download game. Now we can grab the edit text from that board download view, find view by ID with the specified ID, and now the game to download will be the text attribute of this edit text. So I'll say et download game.text.toString.trim. And now we can call our method download game with this game to download string. Okay, let's try it. Let's run the app, and now we should hopefully see one more menu option. Okay, so we do download custom game, And I am going to try out the larger game that we had tried from before, large test. Tap on OK. So this is good. It's promising because I do remember that we had made the large_test game a medium-sized game, which means there are 18 cards or 9 images that we added. And yeah, you can see that this is indeed the images that we had uploaded. So one thing that you'll notice is that there's a little bit of a delay. The very first time that we download that particular image, it takes a couple hundred milliseconds or maybe even 1 second. And then every subsequent time that we download that same image, for example, the Golden Gate Bridge, subsequent times that we display that image is much faster because Picasso is caching that image. Once we've downloaded it once, subsequent times are much, much faster to load. So that's one optimization I'd like to do, which is in the download game method. As soon as we're successfully found the game, one thing we should do is prefetch all the images with Picasso. And this is actually pretty straightforward. I'm just going to say for image URL in user image list dot images, and I'm going to say Picasso dot get, and I'm going to just load the image URL dot fetch. And what this dot fetch is doing is saying, hey, let's go ahead and, even though we're not displaying this into an image view right away, go ahead and download it and fetch it so it's saved in the Picasso cache. And one other thing I'd like to do here as well, actually, is just show a snack bar to indicate to the user that they're playing this custom game. Let's try it. So we have a couple games that we've uploaded so far: large test, play game, test 2, and test 3. Let's try maybe test 3. And one other thing to look for is that the title of the screen in the action bar should also update appropriately when we say this. Test 3. Okay, so we are playing test 3. We got the snack bar. And now you can see that the images are loading much faster, which is a great sign. Now we can play the game like a normal game of memory. One bug you'll notice at the top is the activity action bar title hasn't been updated appropriately. So let's debug that. If we go into the setup board method, that's where we set the title. And so it relies on game name. And the bug here is that the game name should be set before calling the setup board method. So by doing that, now that bug should be fixed. Let's try it one more time. So let's try downloading a game called Game 2. There is no Game 2. What did we call it? Test 2. Awesome. And so you can see how now the title of this activity has changed to be test 2, and we got that snack bar, and we should hopefully be playing this new custom game. And now it feels so much snappier. So that's great. One last optimization I want to make on the Picasso side, which is that there's still no way to avoid the fact that we might have to spend a little bit of time downloading the image the very first time. And so when that happens, in the memory board adapter, there's a nice functionality in Picasso to load a placeholder image while the image URL is being fetched. And so I would like to add that as well. So I'll say r.drawable.icimage. And so we're going to define one more vector asset, which will be kind of the placeholder image, a silhouette of an image, like a black and white image. So let's go into project, go into the resources, and let's create a new vector asset in the drawable directory. Called image. So we'll call this IC_image. And yeah, let's leave it as color gray and then finish. Okay, so this error went away. And let's see if we can actually see the placeholder image. So if we're really quick after we download a game, then we might be able to see it briefly. So I'll say large test. Yeah, and then you might have briefly seen the very first image I flipped over, we were able to see that placeholder image, and all the subsequent images are much faster to load because we're doing that prefetch operation. So that's a really good sign. It's a much better experience now. Before moving on to the next segment, which is focused on design and style improvement, there's one more small improvement I want to make here, which is that if we have this snack bar show up, right now there's no way to actually dismiss it. And it's not that hard to make the snack bar dismissible and give the user more control over the UI simply by going into the activity main. And right now the root element is a constraint layout. If we instead change that to be a coordinator layout, then any snack bar can then be dismissed by the user. So let me do that. So coordinator layout. And then we're going to add a bunch of these properties in the coordinator layout. So copy this, put it at the end. And then I'm going to hit Command Option L in order to fix the indentation. And we also need the layout width and height on the constraint layout, of course. And this ID of CL root, we're actually going to apply that onto the coordinator layout. So everything else is identical because the only time we're referencing CL root is as the anchor for the snack bar. And by making the anchor for the snack bar a coordinator layout, now the user should be able to dismiss the snack bar with more control. Let's try it. Okay, it looks like we are crashing, and I think I know why. Yeah, the reason is because there's a class cast exception. If we go back into main activity, you'll remember at the top of the file right now, we're defining CL root as a constraint layout, but this should actually be a coordinator layout. And here, CL root is finding by ID, and that's fine. So now let's try it. Hopefully we won't crash. So we are able to boot up properly. And if I trigger the snack bar, now you can see how I was able to dismiss it. In the next part, I want to do some low-hanging design improvements with all of you, and then we'll be done with all of the functionality and design for the whole app. In this segment, I want to make a couple of very easy but powerful improvements in the app. The first one is not so much an improvement, but avoiding an issue in the app, which is if you rotate the screen. So you can see that whenever you rotate the screen in Android, the activity is destroyed and recreated. And we are not doing a great job with managing the space here. Our app isn't very smart around when the phone is wider than it is taller, the number of columns in the memory grid should be larger. But right now we're still assuming this portrait mode where we will always have more rows than we will have columns. And so we have two options. One is we could actually properly address this, and that would require some logic inside of the memory word adapter and figuring out how much space to allocate in the width and height. The other option is to do the lazy thing, which is not allow the user to change the mode of these activities to be in landscape. And that's what we're going to end up doing. So if we open up Android Manifest, we have two activities in our app, CreateActivity and main activity. And we're going to update the screen orientation attribute to be portrait. And that's it. That's the only valid option. And by adding this line into the Android Manifest file, even if the screen is rotated, even if the user rotates their phone, then Android won't actually go through the activity lifecycle. We're not going to be destroying the activity, and so we're still looking at the same portrait mode UI, even in landscape. The two-line solution that we came up with here to lock the orientation in portrait is definitely the lazy solution, but I would argue that this is actually a reasonable trade-off to make. Our job as engineers is about efficiency. And so you have to make the decision about how much value are you delivering to users by implementing proper landscape mode in the app versus how much engineering time or developer time would that take? And can you use your time better elsewhere? You can definitely implement this if you want to learn more, but the key takeaway here is thinking about what problem are you trying to solve. The second improvement I want to make is I want to add a little bit more festivity when the user wins the game. So right now, let me quickly see if I can win the game. So we just have this snack bar show up, you won, congratulations. I'd also like to have something a bit more festive, and in particular, I want to have some confetti pop up. And this turns out to be really easy because we can use a library which does this for us. So if you go to your browser and just Google for Android confetti library, you'll come up with this GitHub repository, and this is the one that we're going to end up using. So I'll show you how to use it, but right now all you need to do is copy over this line to add this into your build.gradle file, which is located in the app module. tap on sync now so we can pull this library into our project. And now let's go into main activity and let's figure out where do we actually detect that we've won the game. So as soon as we flip over a card, that's the only time when we have the potential to win the game. And we have this snack bar that we show up right now. So right here is where I'd like to now show this confetti. And it turns out that we can do this with literally one line of code. I'm going to invoke a static method in the library. I'll say common confetti, import this, and we're going to call this method raining confetti. The first parameter here is the container. That'll be the parent element on which the confetti should be falling. So we'll call clroot. And then the next parameter is the colors that you want the confetti to be. So I'll say int array of, and we're just going to pass in some colors that are already defined for us by the Android system. And you can kind of pick whatever you like. Here's the ones I picked: yellow, green, and magenta. In order to actually launch the confetti, we call this method one-shot. And that's it. So let's try it and see how it looks. Amazing. So you can see how this confetti is falling, and there's some like particle physics inside of the library, some math, so that we have some particles, some confetti falling quickly, some falling slowly, and they also will drift side to side. So it's a really nice, simple way to make the app more fun. The next thing I'd like to do is update the color scheme of the app. And there's definitely no right answer here. You can be creative and pick whatever color you like. What I recommend most people do is go to color.adobe.com. And this is a really nice way to pick out a color palette. You can kind of take this, drag it around, and figure out what color scheme you like. And if you don't like this one, which by default is analogous, you can pick out one more, like monochromatic, triad, complementary, or whatever you want. And this gives you a nice working set of colors, which we can then use to update our Android app. We have a couple of different colors, like the status bar color, this action bar color, and this background color of the linear layout. So those are the colors that I want to update. So let's open up the colors.xml file. I'm going to add 3 more colors here. First, we'll define green dark. Then we'll have one more called green darkest, and then a third one called green blue. And you can pick whatever colors you want for this, like we talked about. Here's what I picked for green dark. Green darkest is a darker shade of green dark. And then finally, green blue is a teal. And you can see a preview on the left-hand side. Now we have to make use of these newly defined colors. And we'll do that in themes.xml. We'll define color primary to be green dark. We'll define color primary variant to be green darkest. And notice on line 13, the status bar color is the color primary variant. And finally, in the secondary brand color category, we'll update both the color secondary and color secondary variant to be green blue. One more thing I'd like to call out: dark mode is all the rage these days, and so Android Studio actually has a separate file, themes.xml, located inside of values-night. And so if the app or phone supports dark mode, then the colors inside of the values-night themes file will be red instead of the one that we defined. Just something to keep in mind if you're into that sort of thing. Let's try our app with these new colors. And if we've done our job correctly, we should no longer see this purple color at the top. We should instead be seeing the palette of green we picked out. So we have a green action bar, a darker green for the status bar, and at the bottom, the blue green. The final design improvement I'd like to make is to change the view of the memory card when it's face down, this green grid, because it just feels like our app is still under construction, and instead use some custom image for the default state. So you're welcome to pick whatever image you want for this. I'm going to open up the drawable directory, and the image that I found, I downloaded from the internet, is this picture of bamboo. So everyone loves pandas, therefore everyone should love bamboo. I'm going to drag this bamboo.png file into the drawable directory. Now let's reference this bamboo.png file inside of the memory board adapter, which is where we are setting the icon when a memory card is face down. So right here on line 65 is where we're setting the image resource if the card is face down. And we're going to set this equal to bamboo. So let's run the app and see what this looks like. Perfect. So you can see how now we have the bamboo background and we can play the game like normal. Perfect. Okay, so let's try, just for good measure, let's play the whole game and go through the creation flow as well. So I'm going to create a brand new game. I'm going to have this be easy. I'm going to call this Corgi. And of course, I can't save the game right now because I haven't added the images, but let's add our wonderful images of the Corgi. So I have 4 images of a Corgi here, and then let's tap on save. Perfect. It looks like it succeeded. Tap on OK. And now immediately we go back into the main activity, and we can see that the title has changed to be Corgi, and hopefully we should be able to play our game now. Yay, and you can see that, okay, we have this confetti falling, we have the snack bar, we are recording the number of moves properly, and we have this green text showing that we are 100% done, and we found all the pairs. We can replay the game, and this works because we're still holding on to the image URL list of all these Corgi images, and we can play like normal. I can also choose a different size, so I can pick like a medium-sized board. And here, notice that we are reverting the title back to my memory because this is now playing a default game with default icons. And we're also updating the text at the bottom. And so now we're playing with the default icons rather than the image URLs coming from a user. This looks really quite good. If you've also gotten this far in the game, I would love to hear from you. Drop a comment and let me know. I'll leave you with some extension ideas. The really nice thing about the memory game is that there are so many creative and fun ways to extend the functionality of what we've built together. So one idea I had was simply to add different board sizes. So right now we have 3 enums representing the different dimensions of the board, easy, medium, and hard. We could simply add a couple more enums for different configurations. Another idea I had was to introduce user authentication. And if you allow the user to log in, then you have this really nice ability to be able to see all of the custom games, all the custom boards that logged in user has made. So you have this notion of history or profile for that user. And finally, there could be a lot of interesting work around discovery of other people's boards. So we could imagine there are hundreds of different custom boards created, and I want to see which ones are popular. And I could also enjoy playing other people's games. So if you do end up doing any of these, I'd love to see it. Drop a link to the published app or the GitHub repository, and we can celebrate your app. In the next segment, we're going to prepare our app for release. So I'll walk through a checklist with you about what I typically do before I publish any app on the Google Play Store. If you've gotten this far, I really hope you're planning on publishing what you've built. The app that we have is really full-featured and really fun to play with, and there's a social aspect as well. So in this segment, I want to walk through a checklist of some of the things I always think about before publishing any app onto the Play Store. First is the app icon. So if we tap on the home button and then swipe up to open up the app launcher screen, you can see the app we have here is the default one. So of course, before publishing, we'll want to have a unique app icon for our app, My Memory. You can design the app icon yourself or use a design agency or something like Fiverr in order to get a high quality app icon. Here's what I came up with. It's a grid of 9 squares of different colors to indicate that there's some sort of pairing or matching going on. The main thing to keep in mind with the app icon is that you want it to be square, and you want to avoid text or anything which is too detailed in the image because users won't have that much time or the ability to see your app icon in high-res. So you want it to be very obvious at a glance what your app is. So once you have something you're happy with, then go into the drawable directory, go to New, and tap on Image Asset. And this Asset Studio will help us to create all the different icons that we need, depending on the kind of phone that you have. So I'm going to tap on Path, and we're going to choose that icon that we had just created. So now you can see a preview of how this icon might look. So depending on the kind of phone, if you have a Samsung phone or a Google Pixel or something else, the icon might look a little different, and this is all the different ways that it might be rendered. So I'm pretty happy with that. So we're going to leave the layer name as IC Launcher Foreground, tap on Next, and this is basically just saying that we're going to override the default IC Launcher. So let's tap on Finish. Great, and so now if we run the app, let's see if we actually have the app icon properly reflected. So I'm going to exit the app and go here, and you can see it does indeed show our new app icon. Awesome. So that's one thing you want to do. The other is enabling minification and ProGuard. If you open up the build.gradle file, I can show you what I'm talking about. you should have a section in your app level build.gradle file for release and build types. And what this is saying is, what are the steps of the build process that you want to run on the release build? When you actually publish your app, you're going to be publishing a release build. What we've been doing so far is a debug build. By default, Android Studio is going to have this minify enabled option as false in release builds. It's important that you turn this on to true. And the reason you want to do this is because it will shrink the size of your app. So an app which might be 20 megabytes, with minify enabled, it'll be much smaller than 20 megabytes. In my experience, the size savings can be more than 50%. And the reason app size is important is because users often don't have that much space on their phone, and also people may not have good connectivity. And so a large app may deter them from downloading it from Google Play. And just to demystify this a little bit, when you enable minification, what's happening is there's something called ProGuard. And ProGuard will basically look at all the libraries that your project is including and strip out methods that are not being used or not being referenced. And through that, it's a really nice way to get rid of code and resources which are not referenced and reduce the size of your application or of the APK, which is generated at the end of the day, and that's downloaded onto the device. You do want to be a little bit careful with ProGuard because it's stripping out methods. Sometimes it's a little bit overeager and it may strip out something which you actually do need in your project. And so you want to make sure that you test out your release build properly and make sure there are no issues that come up in the release build that don't happen on the debug build. For example, one thing I discovered after turning on minification is that I previously didn't have, in the user image list, I didn't have this property name images in the data class. And this actually worked fine in the debug build, but when making a release build, this caused a crash. And so I needed to explicitly add property name images in order for Firestore to be able to construct the user image list correctly. Tip number 3 is, if you want to understand better what your users are doing in the app once you publish it, I'd recommend that you integrate Firebase Analytics. And so there's a guide here that you can Google for, but this is a way for you to understand how many users are opening up the app, how many users are taking a particular action in the app, and you can define what that action might be. So that's an option that we're not going to walk through here, but if you really want more detailed analytics about how people are behaving, then this is a good way to do that. One other thing that you want to do for sure is test your app on different phones and different API versions. So right now, we've only tested our app on this Pixel 2 phone, which is running API 29. But you want to make sure that you test your phone on a tablet if you want to target tablets. You want to test it on the most recent API version, API 30, for example. You want to also go back 5 or 6 years and test your app out on a phone which is running API maybe 24, 25, and make sure that everything works. Look in our build.gradle and you can see the minimum SDK version is 21. So you probably want to test a phone running API 21 as well. We've only been testing our app right now on an emulator. It probably is also worth testing on a physical phone if you have one, just because that will give you a genuine experience of how real users will interact with your app. Emulators are great for testing out your phone on very old devices or devices that are physically hard to get a hold of, but it's definitely worthwhile to try out the app at least once on a physical phone. And the final tip I have is to translate your strings. Right now we have a bunch of text that we show to the users. Those are called strings, and these strings are all written in English. For example, here, snackbar.move, we say invalid move. And this is bad practice because if the user is changing the locale of their phone to, let's say, Spanish or Hindi or some other language, then we would want to be able to translate this text into that language. And the way you do this typically is by having all the user-facing strings belong in this strings.xml file. So right now we literally only have one string, which is the app name. But if you wanted to internationalize your app and have it be popular in countries that are not English speaking, then what you'll want to do is move all of these strings out into the XML file and then reference the strings.xml file instead of having hard-coded text. And once you have all the strings in an XML file like this, you can create an additional version of the strings XML for each language. So you'll have one strings XML for English, one for Spanish, one for French, one for Hindi, and so on. So there are probably a bunch of other things that you could do to optimize your release and make sure it's successful. This is a very quick list of what I typically think about when I publish. If you have other ideas or other things on your checklist, I'd love to hear what you do. Let me know in the comments how you think about it. At this point, not only are we done with the debug version of the app, but also the release version, which is the optimized version of our app for publishing. In the next segment, we'll upload our release app to Google Play and create a listing for our app on the Play Store. The goal for this part is to publish our app on Google Play, which is the dominant Android app ecosystem run by Google. Once we do this, we can easily share our app with friends and family, which will be really fun, and you can point to your app in your resume or your app portfolio, which will help you in landing a job. So Google makes it relatively quick and easy to become a developer on their platform compared to the Apple App Store, which is the app store for iPhones and iPads. And there are two big differences between Google and Apple here. One is that it's way cheaper to become a developer for Google. It's a one-time fee of $25 to become a Google developer. Compare that to Apple, which is $99 every year. So that actually adds up really quickly on the Apple side, whereas Google is much, much cheaper. And the second reason that it's easier to become a developer with Google is because the review process for publishing an Android app is much lighter compared to Apple. Google's process for reviewing our app is largely automated, which means that the turnaround time is a lot faster, whereas Apple will have a real-life human manually check your app, and you might be rejected if your app is deemed low quality or if it's doing something that Apple doesn't like. And so there's been a lot of articles talking about the pros and cons of each approach. I would say that the average app quality on Apple is going to be higher because they actually do reject quite a few apps and they have a higher quality standard. But the diversity of apps on Google Play is way higher, with more than 2 million published Android apps. And that's because Google accepts most of the apps that are submitted to the Play Store. And the other impact of the automated review system of Google is that the iteration speed is a lot faster. So with Apple, you might have to wait more than a week in order to get a review and get your update published. But with Google, as you make improvements, those updates will go out faster to the end user. So we're going to spend a lot of time in the Google Play console in order to create a new app and update it with all the information. But before we do that, there are two pieces of prep work that I want to do, one in the emulator and one in Android Studio. So first, in the emulator, this is where I want to spend a few minutes just taking some screenshots of the app. So the way you can do that is Control S on a PC or Command S on a Mac. So we can just take one of the home screen. Why don't we take a screenshot with some of the cards flipped over? Let me try and get a match. Well, that looks good. Let's do one more screenshot here. Maybe we can do a different size over a couple. And then maybe we can also include a couple of the creation flow. And then finally, maybe we can show folks that they can download a custom game. Okay, awesome. So those have now been saved. By default, they're going to be saved to the desktop. We're going to use those later when we create our Google Play listing. So the next thing we'll do is open up Android Studio, and we're going to create a release bundle from Android Studio, and that'll be what we upload to Google Play. If you go into the menu and go to Build and tap on Generate Signed Bundle or APK, you have two options here, an Android App Bundle or an APK. So the Android App Bundle is recommended because it's a newer file format that Google is pushing, and you can kind of think of it like a zip file, which contains other files inside of it. And in particular, it contains the compiled code for your project, plus the resources, and it lets Google Play create an optimized APK that users will get on their device. And so depending on the kind of device and the screen size and other things, Google Play will optimize what code and resources needs to be downloaded by that user, and that results in a smaller download size. So I want to pick Android App Bundle, tap on Next, and here we need to create a key store. And this is a key store is basically a way that Google can validate the authenticity of the developer. And so I'm going to choose the location as the desktop. And then I'll give this a name of keystore.ks. And then provide a password and make sure you keep this somewhere secure, because if you lose this, you're going to have to create a brand new app on Google Play rather than updating your existing app. Same thing with the key. You need an alias, which I'll leave as the default key 0. Use some password here. And then for the certificate, I'm just going to put my first and last name. And that's all we need for now. Of course, my passwords don't match. Let me try this one more time. Okay, seems like that worked. Tap on remember password just so that as we make changes in the future, we don't have to keep typing all this information again. Tap on next, and then we want a release version of the app. And so our app is fairly small, so this building of the release app shouldn't take too long, but if you have a larger app, this can certainly take several minutes. All right, so it looks like we were able to generate the signed bundle, so I'm going to locate it. Shows up over here, and so you can see here the AAB file is 2.5 megabyte, and that's pretty good. It's a pretty small app, and keep in mind that this is an upper bound of the size because the AAB is essentially a zip file, and Google Play will optimize what APK it generates for the user's device. So 2.5 megabytes is an upper bound on the size of our APK. So what I have over here are all the screenshots that we took. So I'm going to drag over the AAB file into this directory. And this is now everything we need in order to create a good Google Play listing. So let's go back now to Google Chrome and go to the Google Play console. I'm going to create a new app. We'll update this with a bit more detail later on, but just for now, I'm going to call it My Memory. The default language is English US. It's going to be a game. This is a free app. And then we're going to agree to a couple of policies, and then tap on Create App. Okay, so Google Play here will walk you through a bunch of different questions and policy things that you need to answer. And then after we do that, then we're going to upload our AAB. So first is app access. In our case, everything is available without special access. There's no such thing as logging into our app. Let's go back to the dashboard. Let's go to ads. We have no ads. Content rating, we need to fill out a questionnaire. So I'll put in my email address. Our app is a game. Tap on next. All right, so the only thing that we have to answer yes to is actually this question, because the app does natively allow users to exchange content through sharing images. That's if you create a new memory board and someone downloads that. That's one way for users to interact with each other. So we tap answer yes on that question, but we can answer no on all of these. All right, and then if you look through, you can see the rating that we got in our app. It looks like, as expected, our app is pretty friendly for everyone. Submit. Let's go back now and see what else have we not done. All right, so the next is the privacy policy. So every app has to have a privacy policy. And typically what I recommend for this is if you don't want to go through the hassle of setting up a website, just create a Google Doc which describes the privacy policy and paste that in. I put that together over here, and I can actually link this if you want to copy a similar privacy policy. I basically took this as a template from some other app. It just describes the app and how we're using some Google services. So I'm going to copy this, make sure it's accessible to anyone with the link, paste that in, tap save, and then target audience. We are going to target anyone 13 and up. If you target people less than 13, there's some other compliance rules that I don't want to deal with around targeting kids. Tap on next, and then our store listing will not unintentionally appeal to children. So tap on no there, and then we're done with this section. Tap save. All right, and then it seems like we have one more section here. Is our app a news app? Answer is no. All right, so we have completed all the questions about the app content. That's great. So now let's actually go into the store listing. I'm going to go to the main store listing, and there's a couple things that are required. Anything with the asterisk is required regarding metadata about our app, like things that are describing our app. So I have a note over here where I spent some time putting together a name, description, and full description. So I'm putting in a name of My Memory Image Matching Game. And the app name was actually really, really important because that's how Google Play will figure out when to surface your app for search queries on Google Play. And I have a friend, Alex, who wrote a really good article about how to think about naming your app. And it really comes down to two things. Number one, know what people are searching for in order to try and find your app. And number two, put those words that people are searching for in the title of your app. And so I'm basically guessing that if people want to download our app, they're going to be searching for things like memory or image matching or game. And that's what I've put in the title. One thing you can do is if you're publishing the same app, I'd love for all of us to be able to find each other and try out the different versions of the app that people have built. So just put your name here. So that way, anyone else who's looking for this particular app, they can find out who made it by looking at the last section of the title. And this topic of SEO or search engine optimization is a huge topic. You can read a lot about how do you game that and how do you make sure that your app gets the best chance at being surfaced. I'll leave a link to Alex's article if you want to learn more about that. So short description is something which is 80 characters or less. So what I did for that is this: a free customizable memory game on Android. Match pairs of images. And then the full description can be a little bit more robust and long. So I'm not going to read it all right now, but basically what I'm describing is that this is a totally free open source app. It's customizable memory game. There are no ads, and I'm documenting some of the main features here. All right, so the next thing is graphics. There are two required graphics, one which is the app icon and one which is a feature graphic. So the app icon has to be 512 by 512. These pixels are exact, so it can't be even 1 pixel off. And then the feature graphic has to be 1024 by 500. And so what I recommend you do for this is open up a program like Sketch. Let me show you what I've done. Here are all of the assets that we used for the memory game. Here's the app icon, which is 512 by 512. And for example, if you wanted to create the feature graphic, you can insert a rectangle in Sketch and then update the dimensions as appropriate. So we'll want it to be 1024 wide and 500 tall. And then you can kind of play with this however you want. Change the color, add in some shapes, add in some images. And then once you're happy with what you have, then you can export both the icon and the feature graphic. Let's come back into the Google Play console and we will drag and drop our feature graphic and app icon. So for the feature graphic, let me show you what I put together. So just a picture of the corgi, just because that's kind of the main custom game that we've created with this same color scheme of the app. Drag that over. And then while that's uploading, I'm going to also upload the app icon. And so what I did for that is what you already saw, just this grid of squares. And so now both the app icon and feature graphic are updated. And finally, we get to the phone screenshots. So I'm going to go back to this directory where we have all the screenshots and drag those out. Okay, that looks good. And you can have up to 8 screenshots, minimum of 2. And there are some really fancy things that you can do to make these look a little bit better, like having some sort of colored background or combining 2 of the screenshots into a continuous shot. But we're going to leave it simple for now. We are going to ignore the tablet screenshots. So we'll just basically reuse the phone screenshots. Same thing with the 10-inch. And then we don't have a video for now. Tap on save. So now we have the basics for our main store listing. We're going to go into the release section, go into production. Here's where we're going to create a new release. And just one thing I'll mention, we're not going to deal with it currently, but there is an option here for testing your app before you do a broad production rollout. So you have open testing as an option or closed testing and also internal testing. These are basically various options to allow you to test out your app with a trusted set of users in your company or with friends and family, or just have an open beta program prior to releasing it publicly. We're not going to deal with any of that, just to keep it simple. So I'm just going to go into production track and create a new release. And we're going to use App Signing by Google, tap on continue. And then we're going to drag and drop our AAB, our Android app bundle. So I'm going over here, dragging that. The release name can be initial release. And then release notes, I'm just going to leave as the default. Tap on save. All right, that looks good. One thing that we'll need to do is specify which countries we want to release our app to. So tap on this add countries and regions, and I'm going to go ahead and select all of them. So we're going to add all 151 countries. Then we're going to go back to releases, tap on edit, and then go to reviewed release. It looks like we have some errors. All right, so it says that our app can't be published yet. Complete the steps listed in the dashboard. So let's see, what did we miss in the dashboard? So we have to specify an app category. Let's do that. We are a game, and in particular, we are a puzzle game. Let's just quickly add a tag called memory. Apply that. Now we'll leave our email address and opt into external marketing and hit save. So now let's go back into the production release section, go into releases, tap on edit, and let's see if we are able to properly release this now. Okay, amazing. So we have set up our store listing properly. We've done all the questionnaires, all the policy agreements, and we can see the Android app bundle, and then we'll hit this button for start rollout to production. So the review process might take a little bit longer now because of coronavirus and the lack of staff. But my experience historically has been that still with a simple app like this, we should be able to get a review and have it approved within 2 or 3 days. Hey everyone, welcome back. The My Memory app that we submitted to Google Play just got approved into the store. So what I want to do in this segment is walk through the Google Play listing, along with doing a quick concept review of everything we've talked about to get to this point, and then we will celebrate. So here's the store listing, and it's pretty much what you'd expect. The app icon and the title are what we submitted into the Google Play console. It shows the developer name here, along with, on the right side, more apps by that developer. So I have 2 other apps live in the Play Store, which you can see here. We have the category of the app, screenshots, description, and then when we get reviews, those will show up over here. This section, What's New, is about release notes. For subsequent versions of the app, you can leave a message to users about what has changed. And the magical thing about software is that it's so easy to change, to iterate, and to improve. So I actually already made one improvement in the app, which is I added a couple more colors into the dark theme so that the app will render better if your phone is using dark mode. So I would encourage you not to view publishing your app into the Play Store as an ending point, but instead as a starting point where now you can make a bunch more improvements in terms of features or designs. At the bottom, we have additional information. For example, when was the app updated? How large is the app? 2.3 megabytes. How many installs does it have? And also requires Android 5.0 and up. And this is coming from the minimum API version of 21 in our app. And it tells users how recent does their Android phone have to be in order to download this app. So the really cool thing about having this app published is now we can take the URL and share that with anyone in the world, and they can very easily download this application, My Memory, on their phone and tablet and play. One of the core features that we built into the app is the ability to create your own custom memory game using photos from your phone. So you're already familiar with the Corgi game that we used during the video walkthrough for the creation flow. I also have one called Bitmoji, which is my Bitmoji character doing different things. And then one more you can try out is the board game I created called Rahul, which is pictures of me just doing various activities. So if you also have a funny or creative custom memory game with your own photos, drop a comment and I would love to play it out. One more note on the topic of publishing. From the time that I submitted the app until it got approved by Google, it was about 3 days. I'm not really sure what the standard is given COVID-19. If you had a much shorter review time or much longer, I'd love to also hear from you. The last thing I want to do in this segment is a review of everything we've covered. So there's a ton of really fundamental concepts that we've learned that you can now apply to whatever else you want to build. We created a brand new Android Studio project. So we started from scratch. And then the main UI of our application is built on top of the RecyclerView. And the interesting thing is that the contents of that RecyclerView will be dynamically measured based on the screen width and height. We also started thinking about how do we use models to represent the different objects in the memory game, the memory card and memory game. And this is going toward the direction of app architecture. So we didn't explicitly talk about different kinds of app architectures, but basically app architecture means how do you organize your code? And so by using the RecyclerView and using the memory card and memory game, we have already a better idea of how to partition up the logic, so it's easier to debug and extend our application. And we also integrated with 2 Firebase services, storage and Firestore, for the creation flow. And finally, we were able to publish our app into Google Play, and we talked about some of the best practices there. So here is that same picture cloud representation that I showed you in the very beginning of all the different things we learned. We made a brand new Android Studio project, so you're definitely familiar with Android Studio now. We talked about how to create vector icons and use that as a default memory card. We talked about views on Android and how they have content, padding, and then margins live outside the view, and we take that into account when creating the view width and height. The recycler view is the core component which is responsible for displaying that grid of memory cards. We talked about how there's a layout manager which puts things in the grid, the adapter which is responsible for binding a view in the recycler view to the underlying data set, which is a list of memory cards. We also are uploading images to cloud storage, and we're using Cloud Firestore as the database, which is associating the game name to a list of image URLs. And then finally, like we just talked about, we are now live in the Google Play Store. So the result of all that work is this, where we were able to create a custom game with these very cute corgis. We won the game, and we have confetti falling, and we have that message at the bottom. And furthermore, anyone in the world can now download our app from the Play Store and play this game as well. Throughout the whole process, if you have any questions or feedback, I would love to hear from you. I'm on Twitter, YouTube, and LinkedIn, and Instagram at rpande1234. So I'd love to connect with you. And as you share the progress of what you're building, or if you just have a really funny or cute custom memory game, please use this hashtag #mymemory in social media. That way we can all see the progress we are all making and give an encouragement or feedback to people. All right, that's all I had for this project. I hope you had as much fun building out this project as I had teaching it. If you want to help me out, hit that like button and subscribe so you can become part of this learning community. Until next time, I hope you're all staying safe, and I will see you in the next one. Bye.